Yes, am I audible? Good morning, am I audible? Yes, thank you. Let us start today's class. Yesterday, we were discussing the concept of hydrostatics on curved surfaces. Let us continue with that. Hydrostatics on curved surfaces. Hydrostatics on curved surfaces. One moment, please. Hydrostatics on curved surfaces. Curved surfaces. We have mentioned that there are going to be two components of forces. One is horizontal component, the other is vertical component, and then we find out the resultant. Okay, so let me quickly summarize. Imagine that you have a container. You have some container like this, for example, and let us say somewhere over here you are having a curved surface. A curved surface. Let us say starting from here. You are having some curved surface. Let me name this surface as some MN surface. Suppose there is some fluid present. There is some fluid present on top over here. There is some fluid present on top. I want to find the force on MN. We have discussed all these things yesterday. I'm just revising quickly. If I want to find out the value of force on MN, then I'm going to say there is going to be something called as horizontal component of force on Mn. So Fx on Mn is going to be equal to gamma into area into h bar of projected area. Fy on Mn is supposed to be equal to gamma times volume, let us say gamma times volume. Now regarding this projected area, let us say this is over here M projected, this is over here N projected. Suppose this over here represents some projected area. This is over here area projected. This is area projected. Let us say the center of this area is somewhere over here. Center is somewhere over here. So from here, if I measure a distance vertically down till here, a distance vertically down till here, let us say this distance over here is representing your h bar of projected area. Fine. This is your projected area. This is the h bar of projected area. Let us say somewhere over here lies the point center of pressure. Center of pressure. That means this distance over here, again starting from here, this distance is going to be equal to h star. This distance is equal to H star of projected area. So let us say Fx is going to act along this particular line. Fx is going to act along this particular line. This is the line along which Fx is acting. Okay, because it should pass through point P, therefore I'm showing it is along this particular line. Now Fy, for Fy, what should I do over here for Fy? For Fy, I'm supposed to take the volume above over here. If I take the volume above over here, then I'm going to have volume something like this. I'm going to have volume something like this. This is a volume I'm going to consider. Now through the centroid of this particular volume, I'm going to have Fy passing. So imagine the centroid of the volume comes somewhere over here. Through this particular point, Fy is going to pass. This is how Fy is passing. Fy is passing. Now what will happen is, I know Fy is passing through this, Fx is passing through this. So what I can do, I can extend the line of action of both these things. I can extend the line of action of both these things. I can say from this particular point, my resultant has to pass. Okay. There's a particular principle known as principle of transmissibility of forces. By the virtue of principle of transmissibility of forces, I can say that Fy, even though it is acting from here, which is centroid of the volume, it is acting through this point, but I can extend its line of action. Likewise, I can extend the line of action of Fx. I can say this is the point through which the resultant is supposed to act. So let us say the resultant is supposed to act through this particular point. The resultant is supposed to act through this particular point. If I take a horizontal, and measure the angle over here as angle theta, then the value of theta is equal to tan inverse of Fy upon Fx. Okay, this is the concept of hydrostatics on curved surfaces. This was just a summary because if you are finding any difficulty within one slide, you can find everything for hydrostatics one moment basis. I hope all of you are following the extension of line of action of Fx and Fy so as to get the point at which resultant is acting. Wherever these two lines are going to intersect through that particular point, you are going to have resultant acting. This is a logic. Okay. Moving further, yesterday we have seen a problem. Yesterday we have seen one problem of the resultant force. Now let us take one more problem. This problem is a very interesting one. Okay. Look over here. The problem goes something like this. Imagine a tank. Imagine a tank. Let us say imagine some tank like this. You're having some tank like this. Inside this tank, let us say you're having some fluid. Inside this tank, you're having some fluid over here. There is some fluid present. But this tank over here is having a semicircular gate. This tank is having a semicircular gate. This over here is a semicircular gate. Semicircular. gate. The diameter of this gate is equal to capital D. Diameter is capital D. Over here it is exposed to atmosphere. Therefore, the gauge pressure on top is equal to 0. The property of the fluid below is gamma. Let us say from here, if I measure the distance below, let us say the distance over here is h till this particular point. Let me name this point a certain point m. Let me name this point a certain point n over here. Okay. The question asked is, question number one, fx on mn equal to how much? Question number two, fy on mn equal to how much? Take unit width perpendicular to screen. Unit width perpendicular to screen. Please try this question. The diagram is pretty clear. You are given some important parameters. You see, H is important over here, gamma is important, D is important. Every important parameter is already mentioned over here. Please start. Fx should be very, very easy. Fx should be very, very easy for you. At least get me the value of fx. For gamma, when you're typing, you can type small r in your answer. For gamma, you can type small r in the answer. चलिए. Fine. Some of you have tried. Now let me try the value of fx. I'm trying the value of fx. We know that. Let us go by the formula always. In this particular case, I'm going by the formula. Fx on mn is basically equal to gamma into area times h bar projected. Gamma into area times h bar projected. Area projected over here is equal to how much? Now this should be very simple. If I look from here, if I am looking from this particular side, let us say m somewhere over here I'm getting, n somewhere over here I'm getting, I'm going to get a vertical line. I'm going to get a vertical line over here. A vertical line over here, that is m projected, n projected, is going to have what height? It will have height exactly equal to diameter. It will have height exactly equal to diameter. So therefore area projected is height is equal to diameter multiplied to. Now width, you see I'm looking from side view over here. I'm looking for the width perpendicular. The width means this thing, width perpendicular, let us say something like this, that is equal to how much? 1 unit width. Therefore, area projected is equal to D itself. Perfect. Next thing, H bar of projected area is equal to how much? H bar of projected area means at this particular point you are supposed to get H bar. How far is it from the interface? To get this thing is very simple. You're going complete distance H down and then you're going half a diameter down. So therefore H bar has to be equal to H plus half the diameter, that is D by 2. H plus D by 2. Now I'm having gamma, I'm having area projected, H bar of area projected. Let me multiply these things. So the value of Fx on Mn will be equal to gamma times diameter times H plus D by 2. One more thing. In what direction is this Fx going to act? Let us think of that also. What direction is Fx supposed to be acting? Very simple. Now you see the fluid is present over here. At any point, the pushing effect is going to be towards the right hand side. The fluid is always, remember this thing, fluid always pushes. It is pushing towards the right hand side. Since it is pushing towards the right hand side, I can say on the gate or on the semicircular gate, Fx is going to act towards the right hand side. This is a direction sense. Fine. So this is supposed to be your answer for Fx. I hope all of you are understanding this thing. Fy is slightly difficult. I want you to give it a try once. I want you to give it a try once to get the value of Fy. Yes. I want you to try the value of Fy. Regarding AP, it is just imagine that you're extending this line, somewhere over here. This is some point M projected, this is some point N projected, you're drawing a vertical over here. How much is the area of this particular vertical? This vertical will have a height exactly equal to diameter. Width perpendicular will be exactly equal to 1. So diameter multiplied to width, that way. Actually, Fy. This is a previous gate question as a matter of fact. Okay. Let me start Fy. Please concentrate on Fy. Okay. Many times I have seen people getting difficulty in Fy over here. Look carefully. Take any particular position over here. At this particular position, if you look at the pressure intensity is going to be like this. The pressure intensity is going to be like this, because of which you are going to have horizontal component of force in this direction, vertical component of force in this direction. You are having vertical component of force in downward direction over here. Now take some position over here, any random position. Okay, I'm choosing any random position. I see that the component of force over here is going to be like this, of which the horizontal will be in this direction, the vertical will be in this direction. Okay, so from here I learn one thing, that on this semicircular gate, the vertical component of forces are acting in downward direction as well as upward direction. Both the directions I'm having vertical component of forces. 1 second, please. Both the directions I'm having a vertical component of force. Okay, in both directions. Over here I'm having in the downward direction, and I'm having over here in the upward direction. So what should I do now? I should first of all identify the point above which I'm having downward direction force, below which I'm having upward direction force. Logically, you're supposed to get that it is exactly the midpoint over here. Let me consider this point as certain point O. I know that from M to O, the force in Fy is going to be downward. From O to N, the force in Fy is going to be upward. Okay. This is a duplicate slide, so I'm going to erase these things. I'm going to erase these things. 1 second. We are looking for Fy only over here. So let us say we are solving for Fy. Fy. We are solving for this thing. I can write over here OM, in the region OM, Fy is acting downward. In OM region, Fy is acting downward. What about ON region? In ON region, Fy is acting upward. Fy is acting in which direction? Upward direction over here. So now what I do, I will find out for OM how much volume is responsible. For OM, if I see, I'm going to take the volume above this particular interface. So let us say I'm going to start over here. The volume above this particular curved surface till the interface. So basically this much volume I'm supposed to consider. This is for OM region. So I can say Fy on OM is equal to gamma times volume 1, and this over here is in downward direction. And what is volume 1 over here? Volume 1 over here is basically, 1 second please, it is the volume represented by this kind of hatching. Now come back to Fy on On. What about Fy on On? It is, let us say, supposed to be gamma times volume V2. Let us say it is in upward direction. Now again, I have to look for what is the volume over here responsible. We know that whenever we see a curved surface, we are supposed to start measuring volume from the interface till the curved surface, whether the fluid is present or not present. So if I start shading the fluid from the interface till the curved surface, I am supposed to get the shading something like this. I am supposed to get the shading something like this much shading. So volume V2 over here is basically, V2 over here is going to be this kind of shading, So now what happens? Net Fy will be equal to how much? Net value of Fy will be vector sum of Fy on OM and vector sum of Fy on OM and On. So now I see that, look carefully over here, this much, look at my cursor, this much portion is experiencing upward as well as downward. Therefore, only this portion will remain. Only this portion will remain. So it is equal to gamma times volume V2 minus volume V1, and this will be in the upward direction. I hope you are following this thing. Volume V2 means this entire volume, minus volume V1 means this volume. So I'm going to have only this portion remaining over here. This portion will be remaining over here, and that value will be equal to how much? Gamma times cross section multiplied to width. That is equal to gamma times. What is the cross section of a semicircle? Because this is a semicircle portion. What is the cross section of a semicircle going to be? The cross section of a semicircle is equal to pi d square by 8, and width over here is equal to 1 unit, and this much amount of force is acting in upward direction. This is the net value of Fy. This is the net value of Fy. I hope you're following this thing. Very good. Now, how V2 minus V1. See, V2 is acting in upward direction. V1 is acting in downward direction. Therefore, V2 minus V1. Are you following? Our direction sense is different. Direction sense. This force is acting in upward. This force is acting downward. I am having, let us say, 10 upward, 3 downward. How much force is acting? Will you say 10 plus 3? No. You'll say 10 minus 3, you'll say. That's way it is. Okay. Gamma should be a fluid only. All the pressures are corresponding to the pressures of fluid over here. Moving further. See, very quickly, please understand, it is all about measuring volume over here. I have given you a note yesterday. Okay, if you have gone through the notes, I have given you a note yesterday which says that the volume should be measured from the interface till the curved surface, regardless of whether the fluid is present or not present. Okay, please stop commenting for some time and listen to this thing if anyone is having difficulty. For MO portion, for the first portion, MO portion, if I start measuring volume from the interface till the curved surface, how much volume can you shed? Think. Okay, please start thinking. Fine. If you start measuring the volume will be this region, this much amount of shaded region. Similarly, for ON, from interface till curve, whatever is from interface till curved surface, you shade the entire region. Okay, don't worry, fluid is present or not present, it is none of your concern at all. Straight away, shade the entire region. So how much will you shade? This much portion you will shade. Okay, who is dominating over whom? V2 is dominating over V1. So you have to say V2 minus V1 because directions are opposite over here. Fy on MO is down, Fy on ON is up. Directions are opposite. Therefore, V2 minus V1 over here. Okay. This is how you're supposed to answer. Net force is in upward because upward force is dominating over here. Chali, moving further. So till now, what I have discussed, let me quickly show you the slides. Today's page number 1 is this page. This is page number 1. Okay, I just discussed again the concept of hydrostatic force on curved surfaces. Then the page number 2 was the question. Page number 2 was question over here. Okay, in this particular slide, you are supposed to find out. I have given you the questions Fx and Fy over here. We have found out only Fx in this part. This is for the answer for question number 1. Answer for question number 1. Next slide is this slide over here. This is page 3 slide. Page 3 slide. So this is regarding the concept of hydrostatics on curved surfaces. Okay, we have seen flat surfaces as well as curved surfaces. Now let us move further. The next concept we are going to start now is the concept of buoyancy. This concept over here is the concept of buoyancy. One of the oldest topics and one of the most important topics, especially for IAS examination. Okay, especially for IAS examination, this topic is very important. Chaliye. Now, what do we mean by buoyancy over here? Imagine that I'm having a container again. Let us start with a container. Let us start with a container, let us say. One moment, please. Imagine you're having some container. In this container, you're having some fluid, for example. Let us say you have some fluid. Some fluid, let us say. For example, you have some fluid. Okay. Let us say the property of this particular fluid is gamma. The property of this fluid is gamma. Okay. Now what I'm doing, I'm taking a particular body and dropping down this body in this fluid. Imagine I take a body and drop down the body in fluid. When I drop down the body in fluid, any of two things can happen. Okay, any of these two things can happen. One is the body might completely submerge. Let us say the body is completely submerging over here. The other is the body might partially be immersed. Let us say the body is partially immersed over here. Any of these two things can happen. Okay. First case, the body is getting fully submerged. Second case, the body is partially immersed. One second. The body is partially immersed. Now, in either of these cases, the body is displacing some volume of the fluid. So first thing to note over here, when a body is dropped into a fluid, into a fluid, comma, first thing that can happen is the body displaces some volume of fluid. The body is going to displace some volume of fluid. For example, first case and second case, in both the cases, you see the darker blue region is basically the volume of fluid that has been displaced over here. Now what happens? The moment body is displacing some volume of fluid, there is going to be hydrostatic pressure intensities acting. So imagine everywhere you are going to have some hydrostatic pressure intensities acting. So the fluid is going to apply some hydrostatic pressure intensities everywhere. Now these hydrostatic pressure intensities are going to create, think logically now, okay, I desperately need your help over here to understand. Okay, whenever, imagine this body over here, one moment please, imagine this body over here. Imagine hydrostatic pressure intensities are enveloping. It is enveloping means encapsulating completely. It is covering this body. When it covers this body, then what happens? There will be horizontal thrust from here, horizontal thrust from here. From both directions, horizontal thrust will be acting. But one important thing is the horizontal thrust from here and here, both of them are going to be equal in magnitude, opposite in direction. Equal in magnitude and opposite in direction. Therefore, first conclusion I can get over here is, the net horizontal thrust on the body due to hydrostatic pressure intensities, pressure intensities is going to become a big zero. Why is it going to become zero? Because he is going to apply something. Imagine I'm looking from this side. There is a force acting from this side. Area projected is going to be there. H bar of area projected is going to be there. Let us say I'm looking from this side. I will get the same area projected. Same H bar I'm going to get. So therefore the force from here and the force from here, both of them will nullify each other. Therefore horizontal thrust is zero. So first thing, buoyancy does not deal with horizontal thrust at all. Then what thrust is going to be there? There is going to be a vertical thrust. Will the vertical thrust be zero? No. The reason is, imagine now, from the previous diagram, look at the previous slide over here. I was having over here MO portion. The upper portion was experiencing downward force. Please try to understand. The upper portion is experiencing downward force. Lower portion is experiencing upward force. the downward force was less because the volume above is less. The upward force was more because the volume over here is more. Same story will repeat over here. Think logically. If I divide this body into two halves, upper half and lower half, upper half and lower half. I don't want to spoil the diagram, so you please imagine. Upper half is going to have volume shaded starting from interface till this particular level. Lower half will have volume displaced starting from this level up till the bottom portion. Therefore, the upward thrust will be greater than the downward thrust. So I can write over here, next point, that the net vertical thrust on the body due to hydrostatic pressure intensities, pressure intensities is not going to be equal to zero. This is not going to be equal to zero. Okay, this is all we have observed. Now I am going to write a statement, important statement over here. Listen to this particular statement. What does the statement say? When a body displaces a fluid. So basically the body over here, body 1 and body 2, both of them are displacing some volume of the fluid. When a body displaces a fluid, okay, comma, then the fluid applies a net upward thrust on the body. It applies a net upward thrust on the body. Okay, this upward thrust on the body is basically known as Beyond force. It is called as Beyond force. Okay, it is represented by F with a subscript B. When a body displaces a fluid, then the fluid applies a net upward thrust on the body, equal to the weight of the fluid displaced. Weight of the fluid displaced. Okay, so this basically means the value of FV has to be equal to gamma times volume of the fluid displaced. Okay, this is the concept of buoyancy. To understand this better, let me do one thing. Okay, first of all, if you want, you can take a snapshot of this particular slide. This is just introduction. To understand this better, I'm going back to the previous slide. Let me go one step more backward. Okay, I'm going to this particular slide. Let me create duplicate of this slide. One moment, please. Please be patient. I'll make sure you understand things. Now look over here. I'm going to solve this question using the concept of buoyancy now. Look over here. If I treat this particular body, MON body, I'm saying MON body, I'm imagining like this. MON has displaced the fluid having a property gamma. It has displaced the fluid having a property gamma. Therefore, what should happen now? According to the rule of buoyancy, according to Archimedes' principle, what should happen now? Therefore, the fluid should apply. The fluid should apply a net upward thrust. A net upward thrust. A net upward thrust. How much thrust? Equal to weight of the fluid displaced. Weight of the fluid displaced. Now this net upward thrust in our language is called as what? In our language it is called as FB. It should be equal to how much? It should be equal to weight of the fluid displaced. Therefore, gamma into volume of fluid displaced. Therefore, the value of FB has to be equal to gamma into volume of fluid. I can say is cross section times width. Cross section times width. That is gamma into. Now, how much volume? Imagine this is a solid body. Imagine, which is basically fluid was supposed to be available over here. According to if I had a complete tank, the fluid would be completely available over here. But since this body is not allowing the fluid to be completely available, he has displaced how much volume over here? He has displaced this much volume of the fluid. This much volume of the fluid. This cross section is equal to how much? The cross section over here is equal to pi by 8 d square, and width is equal to how much? 1 unit. Therefore, the value of FB, which is a vertically upward thrust, is equal to gamma into pi by 8 d square. It is a vertically upward thrust, therefore upward over here. Now you look at this slide. This I have done from buoyancy approach, and look at this slide. Answer in both the cases is coming out to be same. This I have done from FY approach, okay, and this I have done using buoyancy approach. Basically, people think that buoyancy is a new topic. No, buoyancy is the same topic. You are just extending extending the concept of hydrostatic force on a complete body now. This is the concept of buoyancy. I hope this idea of buoyancy is clear to all of you now. I hope this concept of buoyancy is clear to all of you. Very good. Very good. Let us move further now. Let us get back 1 second. See, when you will be getting these slides, you will probably get this slide before. Okay. Listen carefully. When you will be getting the notes, you'll probably be getting this slide before this slide. Okay. But I'll mention over here, treat it as page number 4. In the PDF, you'll be getting page number 4 prior to page number 3. So you adjust those things. Shali. Sir, in all conditions, someone is asking, in all conditions, is the value of Fy equal to buoyant force? No, not in all conditions. Not in all conditions. Okay. But in this particular condition, where you feel that the body is actually displacing some fluid, yes, it is going to be equal to buoyant force. Don't worry. Once we'll keep looking into things, you'll understand better. Okay. Now let us get back to this slide of introduction. Over here, I have mentioned that there are 2 possible types of bodies. There is body 1, there is body 2. Now, body 1 and body 2 are there. What is a condition for body 1 to exist? What is a condition for body 2 to exist? For body 1, the condition is this particular body has to be lighter in density compared to the fluid. Okay, for example, wood, it has a density 600 to 800. Okay, depends. 600 to 800 is wood's density. Water's density is 1000. Since wood is lighter than water, therefore wood should float in water, partially submerged. So for partially submerged body, the gamma of body will be less than the gamma of fluid. Okay, I need not mention this thing. It is very logical, but still I'm writing over here. For body 2, what should happen? For second body, what should happen? Gamma of body will be either greater or it can as well be equal to gamma of fluid. Okay, imagine you're having a steel block. Okay, steel block. Now, in the case of steel block, you won't have surface tension acting. Steel needle, steel blade, fine surface tension is there. Steel block, if you drop in water, it will, for sure, it should submerge down. The reason being density is greater. Okay, if the density happens to be even equal, still it will completely submerge down. It might not accelerate downward, but it shall submerge down. Okay, this is the introduction to the concept of buoyancy. Let me move further. This statement is basically the definition of buoyancy force also. Now, the next point I'm going to mention over here is regarding this FB force. We have mentioned the value of FB. Let me again write FB over here is equal to weight of the fluid displaced. Weight of the fluid displaced. FB is equal to weight of the fluid displaced. Therefore, the formula of FB happens to be equal to gamma times volume of fluid displaced. And this FB shall always be in which direction? Vertically upward direction. It's an upward thrust. Fine, accepted till here. One more point I'm going to write. This point might be new to you. Okay. But this point is very important in some cases. On the body, FB is acting upward. It does not stop over there. Generally, people stop discussing about FB at that point only. What do they say? On the body, imagine that this over here is a body. On this body, FB is acting upward. Now, bring Newton along with this. Newton gave you a law called as Newton's third law, very, very famous law and highly misunderstood, highly, manipulated law. That is action-reaction law. Generally, people think that Newton's third law means for every action, there is an equal and opposite reaction. That is a perfect blunder, mistake. Okay, he never said like this. People just blame Newton like this. He never said for every action, there is an equal and opposite reaction. He said that for every action by a body, there is an equal and opposite reaction on the body. For every action by a body. Imagine this is my right hand. For every action by a body, right hand is pushing over here. Right hand is pushing over here. There is an equal and opposite on the body. So left hand is also pushing him back. That means how many bodies are required over here? 2 bodies. Remember this thing. Therefore, your Newton's third law cannot be applied on a single body. Many good people who know mechanics very well still do mistake in this thing. They think that action and reaction, both of them are on the same body. If you ask them to draw a free body diagram of a particular block, they'll say block ऐसा है, W नीचे जा रहा, N ऊपर आ रहा, W action है, N reaction है. Perfect mistake. Perfect mistake. इससे अच्छा mistake नहीं कर सकते आप. Okay. W and N might be equal, might be opposite, but they are not action-reaction pair. Because action-reaction pair can never exist on a single body. Action and reaction has to exist between 2 bodies in interaction. Between 2 bodies in interaction. Okay. You can refer to some good literature for this thing. I would recommend you Resnick Halliday. Okay. Very interesting discussion he has made on Newton's third law. Now, let us apply Newton's third law over here. Ask yourself, this FB is actually on what are we discussing? This FB is on the body by the fluid. So let me write over here. This FB is, 8 seconds. See, I'm telling you, please be patient and listen to everything I'm saying. And it's not just for the sake of saying like this. I'm seriously saying that if you listen to things like story and whatever I'm saying in sequence, you will understand everything perfectly. and you won't have much effort to put in to understand later on. Okay, so listen to this. This FB I'm discussing is on the body by the fluid. Now, tell FB that there is something called as Newton's third law, which says that if this FB is on the body by the fluid, there has to be one more FB. There has to be one more FB. That FB should be on the fluid by the body. So I can say a note over here, a note over here, which says that, by Newton's third law, by Newton's third law, there has to be FB acting, acting. In which direction now? If this FB action has been done upward, this has to be in downward direction. FB acting downward on the fluid, by the body, on the fluid by the body. So imagine that you're having over here a container. Okay, you're having over here a container. One moment, please. You're having this container over here. There's a certain body you're having. Let us say some body over here you're having like this. This is a body, let us say I'm having. Now we know that if I look at the free body diagram of the body, let us say this is a body I'm having. The free body diagram says W is downward, FB is upward. FB is upward. This is the free body diagram of the body over here. Okay, imagine I'm drawing the free body diagram of the fluid. I'm drawing, one second. I'm drawing the free body diagram of the fluid. Okay, I'm not showing all the forces acting on fluid, but there has to be one force at least you have to show, and that force is FB downward. This is for body, this is for fluid. Since the fluid is up pushing, or it is applying an upward thrust on the body is applying a downward thrust on the fluid, equal and opposite, by the virtue of what? By the virtue of Newton's third law. Okay, this is the meaning of the statement over here. I hope this is clear to you. If it is not clear, then please don't straight away worry about things. Just go through Newton's third law once. Okay, the problem with Newton's third law is it looks simple. It looks very simple because everyone, if you forget about engineers, if you go to an arts class, humanitarian class and all, ask them what is Newton's third law, even though they know the statement as for every action there is equal and opposite reaction. Okay, since the statement looks very simple, and actually the statement is wrong. Statement does not stop over there. Statement further goes on to says between two bodies in interaction, action reaction can never be on a single body. Fine. So since it has been misunderstood for a very long time, generally by students, this understanding, what I have drawn over here, this understanding looks slightly unreasonable first. But don't think it is unreasonable. It is perfectly reasonable only. Okay, why this is important? I'll take a question for you to understand, but excuse me, please. One more note over here. One more note. This FB force, which we are showing, FB, it is a force equivalent to weight of the fluid displaced. Therefore, this FB should pass through the center of gravity of the fluid displaced. FB should pass through the center of gravity of the fluid displaced. FB should pass through the center of gravity of the fluid displaced. Therefore, this point is also known as center of buoyancy. This point is also known as center of buoyancy. And how do we represent this center of buoyancy? We represent this by capital B. So basically over here you're going to have a certain point, capital B, center of buoyancy. Very important. Okay, till now we have seen 3 points: centroid or center of gravity, that is represented by G. We have seen center of pressure in the previous topic, represented by capital P. We are seeing center of buoyancy over here. Okay, later we'll see one more point which is known as metacenter, very famous point. Metacenter also in this chapter itself, buoyancy you'll be seeing. Okay, I hope all these things are clear to you. Still, I am working with the basics. I have not started problems over here. Okay, moving further to the next thing. There are two possible cases. When a body is dropped into a fluid, there are two possible cases. You know, one, it is completely submerged. The other, it is partially immersed. Okay, only these two cases can prevail. Nothing else is there. So let us say, case one, for the partially submerged body. Again, some notes I'm mentioning, just like notes over here. Notes. 2 points I'm going to mention. 2 points. First point over here. For partially submerged body, partially submerged body. Partially submerged body means what? Condition क्या है partially submerged body का? Gamma of body should be less than gamma of fluid. Best example, wood in water, partially submerged body. Okay. For partially submerged body, if the body is unsupported, comma, then weight of body must be equal to, or let me write like this. Then FB, which is actually equal to weight of fluid displaced, will also be equal to weight of body. Will also be equal to weight of body. So basically I'm saying that FB, which is equal to gamma times volume of fluid displaced, is also equal to weight of the body. What do you mean by this thing? Imagine you are having some interface. Over here. There is some interface. Okay. Below you are having a fluid, properties gamma F over here. Okay. I take a body and place over here any random shaped body, let us say some random shaped body I'm having. So in this particular case, let us say center of gravity of the body is over here. This is center of gravity of the body. And let us say center of buoyancy is over here. This is center of buoyancy. Only two forces. The body is unsupported. That means I did not tie any rope over here and holding with some tension T. Unsupported है. It is an unsupported body. बस body है, पानी में रख दिया, fluid में रख दिया. Okay, unsupported floating body है ये. So in this case, only two forces are acting. One force is the weight of the body downward. It is a weight of the body downward. Other force is the FB in upward direction on the body. Now, this body is in equilibrium. If this body is in equilibrium, then what should happen? Whatever is a downward thrust should be equal to upward thrust. Therefore, FB has to be equal to weight of body. This is the point I'm mentioning over here. I hope this point is clear to all of you. One moment, please. Okay. Next, second note we are having over here. Second note. For fully submerged body, for fully submerged body, we have only seen two types of body, partially submerged है या fully submerged है. अब fully submerged body, imagine कीजिए आप एक stone है, you are having a stone, you are having a stone. Suppose there is a tank, very big tank. Imagine कीजिए some big tank you are having. You have some fluid over here. There is some fluid over here, below fluid over here. Water is there. Let us say tank है तो पानी है, water is there. You take a stone, you drop it down. When you drop it down, stone let us say somewhere over here. Then stone let us say somewhere over here. Stone let us say somewhere over here. Three positions I'm taking. First, second, third. Three positions I'm taking over here. In which position? Tell me. Okay, you can type and mention in which position force of buoyancy will be maximum. Force of buoyancy will be maximum in which position? Kalpesh Rajput, I'll come to your question later on. In which position? Very good, Saurav Kumar Thakur. Sahi Mahesh, correct answer. Basi Reddy, correct. Very good. Chaliye. Okay, stop answering now. Stop answering. I got an idea what you want to answer. Okay, stop answering for some time, please. Now, the thing is, the value of FB, ask yourself what is the value of FB. Value of FB is equal to gamma times volume of fluid displaced. If the body is fully submerged, the volume of fluid displaced every time is going to be same. Here, here, everywhere the volume of fluid displaced is going to be same. Chaliye, volume of fluid is constant. In 1, 2, 3, in all three cases, volume of fluid is constant. What about the value of gamma? In fluid, let us say, in a tank, water is there. Let us say the value of gamma also is constant. If the value of gamma is constant and the value of volume of fluid also is constant, this basically means FB has to be independent of depth of submergence for a fully submerged body as long as density of the fluid remains constant. So let me mention over here, for a fully submerged body, FB is independent of the depth of submergence, depth of submergence, depth of submergence, comma, as long as the density of fluid remains constant. The density of fluid remains constant. As long as the density of the fluid remains a constant, FB will be independent of depth of submergence. Okay. The first point over here is for which body? Partially submerged body, if unsupported. Unsupported, partially submerged body. The second point is fully submerged body, as long as the density of the fluid remains constant. If density of the fluid is increasing, then FB also will increase. Imagine seawater. In the case of seawater, as you go into deeper and deeper depths, the density of the seawater slightly increases. Therefore, FB should also increase. Okay, Chali, this completes the first part of the buoyancy topic. It is just introduction, the concept of FB, the concept of center of buoyancy. That much only. Based on this, let us do some problems. Problem number one. Okay. Problem number one has been asked multiple times in many interview examinations also. Okay. But before I start problem number one, I'll ask you something that imagine you're standing on a weighing machine. What exactly does the weighing machine measure? What does it sense first? Okay. When you stand on a weighing machine, what does the weighing machine measure? Force accepted, sir, but which force? Very good. Sanket Salunke. Perfect answer. Shiva Ganesh. Correct answer. Generally, this answer people give is wrong. Okay. Stop answering now. Okay, stop answering now. Let me see. What does a weighing machine measure? Please understand that whenever you stand on a weighing machine, think logically now. This is a weighing machine, let us say. Here you're standing on a weighing machine. If you look at your free body diagram, if I look at your free body diagram, on you, there is a force W acting. People think there are many misconceptions actually in the concept of free body. People think W is a force which body is creating. Galat hai. W is not a force which body is creating. W is a force acting on body. Acting on body. By whom? By Earth. Actually, it is Earth which is pulling you down with W. Okay, fine. But that is not important for me. For me, weighing machine, what is doing is important. The moment you stand on a weighing machine, what weighing machine does is it applies a reaction force on you. I prefer calling it as a normal force. There is a logic behind the word normal also, why normal is used. Okay. Anyway, so the weighing machine is applying a normal on you. Why is it applying a normal on you? Because you applied a normal on weighing machine. So please understand, the weighing machine does not measure the weight. Weight is a force acting on you. On the weighing machine, normal is acting. On the weighing machine, normal is acting. Please understand this thing. Okay. On the weighing machine, normal is acting. Okay. Okay. On the weighing machine, normal is acting. Incidentally, over here, normal is equal to weight. Therefore, everything is fine. Chali. Now forget about all these things. Forget, nahi, just remember these things. Let us come to our question. Okay. These are some of your basic mechanics. Don't worry, I won't trouble you with lot of mechanics after this chapter. After this chapter, I'll trouble you with mathematics. Okay, that will be a different story altogether, kinematics and all. Okay. There people start hitting me in kinematics. Look at this question. Imagine कीजिए कि there is a particular tank. Below this tank, let us say there is a weighing machine. Below this tank, there is a weighing machine. Weighing machine over here. Fine. Let us say I am having some fluid present over here. There is some fluid present over here. Some fluid is present over here. Forget about the tank's self-weight. Forget about tank's self-weight. It is given that, given to you, given that weight of fluid is equal to some 500 newtons. Weight of fluid is equal to 500 newtons. Now what I do is, I take a body. I take a body, place this body inside over here, place this body inside over here, and I tie a rope to it. I tie a rope to it. 1 second. I tie a rope to it, and I'm holding with certain tension over here. I'm holding with certain tension over here. Okay. Given to you that weight of body, weight of body is equal to some 800 newtons. Buoyant force is equal to some 200 newtons. This much is given to you. Question number 1. What is the reading on weighing machine? Reading on weighing machine. Question number 2. How much tension is there? How much is tension? Numbers are very, very simple. No need of calculator. Soji, this kind of question is a good question for GATE, good question for IAS, very, very good question for interview. As a matter of fact, the concept of buoyancy is one of the favorite topics for interviews. People love buoyancy in interviews. Those who are asking, of course. Those who are replying, depends. It depends on you. Bhushan Patil, very good. Very, very good. Jerry Arun Thomas, I hope you have answered for question number 1 because that is correct. Tej Kulkarni, you are supposed to assume the body is in equilibrium as long as something opposite is not mentioned. Harish, standard mistake. Nikhil, also the answer I think is wrong. Chali, very good. Now you see numbers are very, very simple. So I hope you have tried. I'm creating a duplicate slide where I'll be doing the solution. The previous slide is as it is. Don't worry about the previous slide. I'm doing the solution duplicate slide. I'll be erasing all these things now. Chali. Please listen to this carefully. The answer over here. Let me write the answers. The answers over here are supposed to be what? I believe the answer for the first question, I think question number 1 has to be 700 newtons. Question number 2, I believe the answer should be 600 newtons. The answer should be 600 newtons. Let us see. Okay. If you're getting the answer, I appreciate it. Very good. Okay. If you're not getting, please listen over here. If you're getting, still listen. You might see, listening to one story again will give you an insight. Okay. Only one story is generally in any concept, only one story will be there. But multiple times, if you listen, you will get some new ideas of approach. Okay. That is why I recommend listening, even if you know. Let us see. I'm drawing the free body diagram. Even if I solve this thing, many of you will have difficulty because you are having difficulty with the concept of free body. इसीलिए be patient, go through the concept of free body again, go through Newton's third law again, and then again approach this question later on in the evening probably. Let us see. There are three important things I'm going to draw over here. First thing is the weighing machine. This is weighing machine. Next thing over here is the fluid. This is the fluid. Next thing over here is the body. Three things I have drawn. Okay, first of all, ask yourself, is the body having any interaction with the weighing machine? Is the body having any interaction with the weighing machine? Answer is no. Body has no interaction with the weighing machine at all. No interaction. It is not in contact. Nothing is there. No interaction is there. But body and fluid, yes, they are having interaction. What interaction is there? See, the fluid is pushing the body upward, with FB. Therefore, the body is pushing the fluid downward with FB. अब देखिए एक्शन रिएक्शन आ गया. क्या एक ही बॉडी पे आया? Did the action reaction appear on a single body? No. Action reaction has appeared on a pair of bodies in interaction. Next thing. The fluid, that is a container basically, the fluid in the container, is it having an interaction with weighing machine? Yes, it is having. The fluid is, or the container is trying to push down this weighing machine with some force. We prefer to call that force as normal force. Therefore, I'm supposed to have a normal over here. Again, you see action reaction pair. Next thing, Earth is pulling him down with a force W. W of what? W of body. Earth is pulling the fluid down with a force W of fluid. W of fluid. Next thing, your hand is applying certain tension over here. That's it. This is the free body of the entire system. Free body of entire system. Now, entire system is in equilibrium. Remember, okay, I have not mentioned over here specifically it is in equilibrium, but it is a logical thing. It is in equilibrium. If it is in equilibrium, let us say for the fluid first. For the fluid, I'm applying sigma Fy is equal to 0. तो क्या बन जाएगा sigma Fy equal to 0? Upward force should be equal to downward force. N must be equal to Wf plus Fb. अब Wf कितना दिया था मैंने? How much did I give? Wf कितना था? 500. Fb कितना? 200. Wf is 500 newtons. Fb over here is 200 newtons. This is equal to how much? 700 newtons. This is your normal. This is your normal. I asked you question number 1. What is a reading on weighing machine? I told you that weighing machine should read normal. Therefore, this is the answer for question 1. Question 1's answer. Now coming to question 2, this should be even simple. On the body, again the body is also in equilibrium. Sigma Fy is equal to 0, I'm writing. Upward thrust over here is T plus Fb has to be equal to Wb, implies T has to be W of body minus Fb, which is equal to W of body 800, Fb 200. Therefore, this is supposed to be equal to 600 newtons. This is the answer for your question 2. If you understand free body diagram, you understand the answer. If you don't understand the free body diagram, you will have difficulty. Standard mistake kahan pe hota? What is a standard mistake? People think that they are supposed to add these two things and subtract this thing, because आपके दिमाग में आ गया कि FB हमेशा ऊपर है. That is wrong. FB हमेशा ऊपर किसके लिए है? FB is always up on what? On the body. FB acts downward also na, on the fluid. Next thing, people are adding 500 and 800 thinking both of them are weights, downward double. But weight of body has nothing or no influence whatsoever on the weighing machine. On the weighing machine, weight has no influence over here. Still, if you're having difficulty, the slide will be with you. You can take a snapshot. You can go through the concept of action, reaction pair and all. Think over it, because this kind of questions will not only appear in your GATE or IAS and all. They'll appear in interviews also, these kind of questions. Anyone wants to take down quickly. This was the first slide, question slide. This is a solution slide. Moving further. Moving further. Next slide. Let us say. Let us take some more questions. Question. From this question, you are going to get a result. I would recommend you to remember the result and please stop commenting for some time. Okay. You give me some time. You give me some time to discuss the concept. Okay. I want you to remember the answer for this result. It will be helpful for you. Okay. This is a standard relationship actually. Let me first of all complete the diagram. Imagine a container. Please do not comment for some time. Imagine a container over here like this. You are having certain prismatic body. You are having some prismatic body over here, which is floating. Let us say the prismatic body is something like this. This is a prismatic body we are having, okay, which is floating. Let us say uh, the fluid is having a property. One second. The fluid over here is having a property SF. Fluid has a property SF. The body has a property SB. This is a prismatic body. Prismatic body. Okay, prismatic body. The value of SF over here is greater than SB. That means the fluid is heavier in density. Okay. The entire height, let us say, the entire height of the body is capital H. The entire height of the body is capital H. Question number 1 over here is, what is the value of small h equal to? Question number 1, what is the value of small h equal to? Question number 2, later on in the second part of the buoyancy chapter, a concept known as metacenter will be important. Metacentric height will be important, wherein a length known as BG length will be important. A length known as BG length will be important. Okay. BG length means what? The distance from center of buoyancy to center of gravity. Okay. The distance from center of buoyancy to center of gravity. For example, 1 minute please. Look over here. BG distance kya hai? BG distance is this particular distance is your BG distance. This is BG distance. So I am asking over here in this question, how much is the value of small h? How much is the value of BG? You are supposed to get the answer in terms of SB, SF, capital H. In terms of SB, SF and capital H. This is the question we are having. Very simple question. See, whenever you are seeing an unsupported floating body, याद रखिए इसको, बहुत बार question आएगा. You will find unsupported floating bodies multiple times. Straight away start with the equation. The value of FB is also equal to weight of the body. The value of FB is also equal to weight of the body. From here, something you will get. FB is equal to weight of the body. Now, FB, standard FB का formula क्या है? FB is equal to basically gamma of fluid multiplied to volume of fluid displaced. Okay, this is equal to. What is the formula for weight of body? It is gamma of body multiplied to volume of body. ठीक है. This is the value. Now, since it is prismatic, since the body is prismatic, the body is prismatic. Prismatic means cross section is constant. Prismatic. I can say, therefore, area has to be a constant. Therefore, area has to be a constant. Therefore, I can write this equation as, this equation again I'm writing, gamma of fluid multiplied to cross section area multiplied to. For fluid displaced, how much height is there? Small h is there. Has to be equal to gamma of body multiplied to cross section area multiplied to. For the body, how much height is there? Complete height is there. So I can cancel off over here area and area. If I cancel off area and area, from here it implies that the value of small h has to be equal to capital H multiplied to gamma of body by gamma of fluid. We know the ratio of gamma to gamma is as good as S to S ratio. From there I can write SB upon SF. The value of small h is equal to, this is the answer for question number 1. Small h is equal to capital H into SB upon SF. I would recommend you to remember these answers for prismatic bodies because many times you are going to see prismatic body questions. Looking at question number 2 now. Looking at question number 2, we know that, imagine this is the body we are having. This is the body we are having. At certain point over here, at exactly center point, I am supposed to have G. Exactly center point, I'm supposed to have G. And somewhere over here, I'm having B. Somewhere over here, I'm having B. I know that the distance from bottom till G has to be equal to capital H by 2. The distance from bottom till B has to be equal to small h by 2. Small h by 2. This implies that the value of BG has to be equal to capital H by 2 minus small h by 2. Small h by 2, or let us say it is equal to half of capital H minus small h. Minus small h. I can write it as half of capital H minus. In place of small h, I can put in this value, that is capital H into SB upon SF. Therefore, the value of BG has to be equal to, let me write in red now, its answer. The value of BG has to be equal to how much? Capital H by 2 multiplied to 1 minus SB upon SF. This is the answer for question number. Answer to question number 2. I hope you are following both these answers. Okay. Thank you, Sanket Salunke. Chaliye. I hope this is clear to all of you. The purpose of taking prismatic body over here. Now understand what is the purpose of taking this question. See, many practical applications are going to have floating bodies only. आप जितने भी applications लेंगे practically, maximum number, okay, majority जो है floating body पे रहेगा. अब फ्लोटिंग बॉडी में सिर्फ 2 कंडीशंस हो सकते हैं, या तो प्रिज्मेटिक रहेगा या नॉन प्रिज्मेटिक रहेगा. ओके, अगर आपके 1 मार्क क्वेश्चंस हैं या आईएएस क्वेश्चंस हैं तो मोस्टली प्रिज्मेटिक बॉडी पे आ जाएंगे. If there are 2 mark questions, then those questions can be on non-prismatic body. So next question we are going to see is the case of non-prismatic body over here. If you want, you can take see, prismatic body basically means कोई बॉडी जिसका क्रॉस सेक्शन थ्रू आउट सेम होगा. ओके, आप पिलर ले लीजिए अपने घर में, आप पिलर ले लीजिए, बीम ले लीजिए, अपने सीलिंग पे जो बीम होता है बीम ले लीजिए, तो ये इनका क्रॉस सेक्शन हमेशा कांस्टेंट रहेगा, उसको प्रिज्मेटिक बोलेंगे. सिलेंडर एग्जांपल है प्रिज्मेटिक का. नॉन प्रिज्मेटिक बोलेंगे जिसका क्रॉस सेक्शन जो है वेरी करेगा. अब देखिए सेकंड केस जहां पे मैं नॉन प्रिज्मेटिक बॉडी लूंगा. लेट मी सी अ केस ऑफ नॉन प्रिज्मेटिक बॉडी नाउ. This has appeared as a question probably in some books. I'm taking a non-prismatic body. Non-prismatic. Okay, please don't comment for some time. Body. And this time I'm taking a cone, for example. cone. Let us take a case of cone for example. Imagine कीजिए a container again. Let us imagine a container again. Suppose there's a cone. There is some cone, let us say like this. There is this cone over here. Okay. This cone, let us say again, the fluid is having SF, the body is having SB. The diameter of the cone is given as capital D, is the diameter over here. The diameter of the cone is capital D. The complete height of this cone is equal to capital H, let us say. Complete height of the cone is capital H. इस पॉइंट को आप कहेंगे एपेक्स, एपेक्स ऑफ कोन कहा जाता है इसे, ठीक है. दिस इज एपेक्स. नाउ 1 second. This diameter is small d. This height over here is small h. This height over here is small h. Given to you are SB, SF, capital H, capital D. These things are given. Also given that okay, floating body है, मतलब तो logical ये है कि the value of F over here has to be greater than SB. This is given. You have to find. This is slightly difficult question. You have to find first thing small d, next small h, then the value of BG. See, when I say the question is difficult, what has made this question difficult? Pichla sawal, the previous question over here was a 1 mark question. This question over here is a 2 mark question. But the concept in both the questions is same. The approach is going to be same in both the questions. What has made that 1 mark question a 2 mark question over here? It is the difficulty in mathematics. Please remember, understand the psychology of examination. एग्जामिनेशन में आप जा रहे हैं तो आप एक जंग पे जा रहे हैं. जब आप जंग पे जाते हैं तो सामने वाले के भी मतलब आप उसकी साइकोलॉजी को समझना जरूरी है, ठीक है. सो यू हैव टू अंडरस्टैंड दैट an examination is trying to upgrade its 1 mark question to 2 mark question by making the mathematics in that question difficult. There are two standard ways of making a question difficult. Either make the mathematics difficult or merge two subjects. For example, you take fluid mechanics and mechanics together, mix them together, create a question. This question will be difficult. This question should be difficult. Okay. For example, we have seen questions like this in examination. There is some truss system. There is a particular body over here. There is a fluid over here. He's asking what are the, let us say for example, in this particular member, what is the loading you are going to have? For example, okay, this kind of question. It's not difficult, of course, but you see, there are two concepts involved. यहाँ तक loading में you are going to have the concept of FB involved. ये हो गया कहाँ से? Fluid mechanics. ये हो गया FM. और बाकी का क्वेश्चन क्या हो गया? It has become a question of engineering mechanics, or you can say structures, whatever. Are you following this thing? So the psychology of examination is either to make the mathematics difficult या दो subjects को लेके आ जाओ. अगर दो subjects को लेके आएंगे तो फायदा क्या होगा? How is he going to get advantage out of it? The logic he has is, let us say someone studied only FM, still he is not able to answer this. Someone studied only EM, still he is not able to answer this thing. A person can answer when he knows both the subjects over here. Okay, this is basically the psychology of examination, competitive examination. Please understand, how much ever good you are in your university examination, you have to change the approach for competitive examination. ये अलग गेम है. ओके, एक टेस्ट प्लेयर जो है T20 में अच्छा रहना जरूरी नहीं है, और T20 प्लेयर तो वैसे भी अच्छे नहीं रहते टेस्ट में. ठीक है ना? सो प्लीज अंडरस्टैंड व्हाट गेम यू आर प्लेइंग, अकॉर्डिंगली यू प्लान. चलिए, नाउ हाउ डू वी स्टार्ट अप्रोचिंग दिस क्वेश्चन ओवर हियर? See, again, it is equilibrium only. You are having an unsupported floating body. You are having an unsupported floating body. So I'm going to again start with the concept of equilibrium. So let us say, question number one, my aim is to identify the value of small d and small h first of all. Excuse me. Solution. I'm again going to start with the value of FB over here has to be equal to weight of the body. Why weight of the body? Because it is an unsupported floating body. Achha. FB is equal to how much over here? FB is equal to gamma of fluid into volume of fluid displaced is equal to gamma of body into volume of body. So this is gamma of fluid into. Now you should be knowing the volume of a cone. Volume of a cone. You see, this portion again is going to be a cone, a smaller cone. The volume of cone is 1 by 3 pi r square h, or you can say 1 by 12 pi d square h, pi d square h is equal to gamma of body into 1 by 12 pi capital D square capital H. Okay. Now 1 by 12 and pi 1 12 tha. Printing mistakes. Morning classes, these things happen. Printing mistakes. Chaliye, 1 by 12 pi got cancelled off. 1 by 12 pi got cancelled off. So from here I conclude that the value of small d square into small h upon capital D square into capital H happens to be equal to how much? Happens to be equal to gamma of body upon gamma of fluid, which further implies small d square small h upon capital D square capital H is equal to SB upon SF. SB upon SF. Now what to do? What is the next thing I'm supposed to do over here? I'm supposed to start thinking. My concept has finished. Iske aage my concept is not going to help me. Okay. Buoyancy concept finishes over here. I have to now think logically. If I look at the front view of this particular image, imagine the front view of this particular image, what are you going to see? You're going to see a set of similar triangles. You're going to see a set of similar triangles. Let us say the front view over here. Is helping you with similar triangles. This is, let us say, front view. Front view. This is over here capital D. This is over here small d. And the entire height over here is equal to capital H. And this height over here is equal to small h. I know that by similarity of triangles, by similarity of triangles, what should happen by similarity of triangles? The value of small d upon capital D has to be equal to small h upon capital H. Small d upon capital D has to be equal to small h upon capital H. Therefore, or this implies that this particular value, I'm looking at this, let us say this was equation number 1. Equation 1 can be mentioned as small d cube by capital D cube. How did we do this thing? You see, small h by capital H I'm replacing by small d by capital D is equal to how much? SB upon SF. SB upon SF, which implies small d has to be equal to capital D into SB upon SF whole power 1 by 3. I hope you are following this thing. I hope you are following this thing. Ashish Power, there is no need of integration over here. Cone is a very standard body. We have some relationships for cone. Okay, fine. This is clear, I hope. Okay, I found out the value of small d. What next? Small h. Very simple. Small h is very simple. One second. Let me create duplicate over here. Duplicate. Sorry. 1 second, please. Previous slide, we were having this thing. We have found the value of small d. Now let us look for the value of capital D. Sorry, small h. I can again say the value of, we were having an equation. Small d square into small h upon capital D square into capital H was equal to SB upon SF. I can also write this equation as small h cube upon capital H cube is equal to SB upon SF, which implies small h is equal to capital H into SB upon SF whole power 1 by 3. Okay, till here I hope everything is fine. Now coming to the concept, we have got the value of small h also. Now coming to the concept of BG, again let me draw a cone over here. One second. Let us take a cone over here. Okay, this is a cone, let us say we are having. Suppose somewhere over here, I have the point G. Somewhere over here, I'm having a point B. Let us say apex I'm representing by O. Over here. Now, I know that the value of BG has to be equal to how much? It has to be equal to OG minus OB. Now, what is the distance in the case of cone? The distance is equal to 3 by 4 of capital H. Standard values are here. Okay, 3 by 4 of capital H minus OB is equal to how much? 3 by 4 of small h. 3 by 4 of small h. Okay, so I can say this is equal to 3 by 4 of capital H minus small h. Fine, I've got this value. Now what I'm going to do, in place of small h, I'm going to put in this value. So I see BG is equal to 3 by 4 of capital H minus, in place of small h, I'm putting capital H into SB upon SF whole power 1 by 3. From here, I can say the value of BG comes out to be equal to how much? 3 capital H by 4 into 1 minus SB upon SF power 1 by 3. This is the answer to the question. I hope you are following all these things. No, you don't have to remember the result for cone. First of all, I don't like remembering things. Okay. The previous slide I asked you to remember because बहुत questions वहाँ से आते हैं. The previous thing, cone and all, no need to remember. Don't remember all these things. I'm just showing you this is the result. Okay. How it is 3 by 4, you should know these values. In the case of cone, it is 3 by 4. In the case of triangle, it is 2 by 3. Yes, standard values hai. It is better if you can remember them. Okay. So these are some standard questions you are having in the case of buoyancy concept.
Let us now move further to one more type of question that appears in examination. That question is regarding the concept of apparent weight question. If you want, you can take down a snapshot of this particular slide. You can take a snapshot of the slide. I'll move further to the next question now. Let us start this thing. This concept, okay. Which one you have to remember? See, I asked you to remember this thing. Okay. Prismatic body, it is not compulsory, but I would recommend you to remember this result. Okay. जब आप अपने short notes लिखेंगे, when you write your short notes, see to it you are writing this result. It will be helpful for you, because sometimes, especially IES people, what happens? Sometimes you won't have that much time in examination to solve questions. You can straight away take this result, because mostly prismatic body appears in examination. The second case, I just showed you how to approach a non-prismatic body. You'll have to take the help, the aid of mathematics over here, logic over here, and do it. Okay. How G is above B? Simple logic. For this smaller cone, its centroid will be somewhere over here. For the bigger cone, of course, the centroid has to be somewhere up. This is G, smaller cone centroid is B over here. Sorry, let us now move further. Look at this concept. Expect questions from this concept also, what I'm discussing now. This is known as apparent weight. Apparent weight. Apparent weight. As a matter of fact, we have partially discussed the concept of apparent weight previously itself. Okay, in one question, we have partially discussed the concept of apparent weight. But still, let me mention over here. Again, these containers are not stopping to. Imagine you have a container. You have some container over here. 1 second. Suppose there is some fluid present over here. There's some fluid present. You take a particular body, hang that body inside this fluid, taking a rope, let us say over here. Okay. You have chosen a body, some body you have chosen. Let us say this is a body you have chosen, and you are hanging this body, or you're holding this body with a rope, let us say, tension T over here. This body is having certain weight of body, let us say W, B is the weight of body. Fine. If I draw the free body diagram, only of the body we are drawing now, this case. If I draw the free body diagram, let us say this is the body I'm having, body. I'm going to have a force coming down that is equal to weight of body. I'm going to have a force upward that is equal to FB. Apart from this, I'm having one more force upward, that force is tension. So I can say by equilibrium, the value of tension plus FB has to be equal to weight of body, which implies tension has to be equal to weight of body minus FB. I hope this is very clear to everyone. This is perfectly all right, I believe. Now, what is this apparent weight over here? Listen to this. When you're holding this body, your hand is feeling that whatever tension is there, that is appearing to you as the weight. When you're holding the body, okay, imagine this tension over here. This tension over here is basically when I'm holding that particular body using a rope. So when I'm holding this body, whatever tension my hand is experiencing or my hand is lifting with, that is appearing to me mentally as the weight of the body. That appears to me as the weight of the body. So now this is basically known as your apparent weight. It is known as apparent weight. How much is the apparent weight supposed to be equal to? Apparent weight is supposed to be equal to weight of body minus buoyant force, Okay. Very good example is when you go into a swimming pool, what happens? Your weight is downward. There is a buoyant force upward thrust pushing you upward. Since buoyant force is upward, weight is downward, you're going to have a difference between these two. That is what mentally you're feeling your weight is. That is why it is called as apparent weight. It is not actual weight. It is appearing to you like the weight. Therefore, it is called as apparent weight. I hope this is clear to all of you. Now, where does the concept of apparent weight become important in examination? They can ask you questions regarding apparent weight of a particular body in two different fluids. अब imagine कीजिए आप कि there are two fluids, let us say. Okay, this bottle is in this bottle you are having a fluid. Over here, let us say, example, say this is one more fluid. Now what I'm doing, I'm placing a body inside this fluid, then I'm placing the same body inside this fluid. Okay, when I place a single body in two different fluids, look over here carefully. The weight of the body shall remain constant. But what about the buoyant force? Will it remain constant or differ? It differs. Buoyant force is going to differ. So if it is differing, apparent weight will differ. That means a single body can have multiple apparent weights. Okay, for example, I take a steel block, I place it in water, I'll have an apparent weight. I place it in kerosene, different apparent weight. I place it in not mercury, let us say. I place it in petrol, a different apparent weight. Every time I use different fluids, FB keeps on changing. Since FB changes, apparent weight also shall change. Apparent weight also shall change. This is where they ask you question. Okay, the question over here will be in the concept of ratio of apparent weights. Ratio of apparent weights of a single body in different fluids. Ratio of apparent weights of a single body. We are taking a single body in different fluids. Therefore, we are getting multiple apparent weights. So let us say, using this particular equation as our formula, this is, let us say, equation 1. Using this equation as formula, I can write over here apparent weight in case 1 upon apparent weight in case 2 has to be equal to how much? It has to be equal to actual weight of the body minus force of buoyancy in case 1 upon actual weight of the body minus force of buoyancy in case 2. Okay, this implies apparent weight in 1 upon apparent weight in 2 has to be equal to. Now look over here. Weight of body minus FB1, weight of body minus FB2. This is a fully submerged body we are speaking about. We are right now speaking about a fully submerged body. That means whatever is the volume, look at my cursor, please. Look at my cursor. Whatever is the volume over here, same volume will be over here. Because body is going to have same volume as the volume in the fluid displaced. So therefore I can say gamma of body into volume minus gamma of fluid 1 into volume divided by gamma of body into volume minus gamma of fluid 2 into volume. Gamma of fluid 2 into volume. Now you see, if volume everywhere is same, I can take it as common. I can cancel it off. I can cancel it off. I can cancel it off. If I cancel this off, what do I get next? I get over here apparent weight in case 1 upon apparent weight in case 2 has to be equal to gamma of body minus gamma of fluid 1 upon gamma of body minus gamma of fluid 2. Again, you are having ratios over here. Therefore, you can say apparent weight in case 1 upon apparent weight in case 2. This will be equal to, since I can say ratio of gamma is as good as ratio of specific gravities, I can say SB minus SF1 upon SB minus SF2. This relationship, it is better if you remember. The ratio of apparent weight of a single body in two different fluid is equal to SB minus SF1 upon SB minus SF2. Okay. Why this relationship is important? Direct questions can appear. Direct questions can appear on these kind of relationships in examination. Okay. You can take a snapshot of this particular slide. Take a snapshot. 1 second. Now let us move further. After this, one more formula I'm going to write now. Okay, previously, let me just mention over here what formula we have seen previously. Apparent weight in first fluid upon apparent weight in second fluid is equal to SB minus SF1 upon SB minus SF2. This was the equation we have seen previously. Let us now write one more equation over here, one more problem, one more formula that is created, and that is ratio of apparent weight to actual weight. Ratio of apparent weight to actual weight. Ratio of apparent weight to actual weight. Now, what is the ratio of apparent weight to actual weight? Let us say apparent weight upon actual weight will be equal to how much? Let us get back to the previous slide to understand this thing. Imagine in place of apparent weight, यहाँ पे मेरा cursor देखिए, look at my cursor. In place of apparent weight 2, if I was writing actual weight, then what would happen? FB2 would not be there. Gamma F2 would not be there. Gamma F2 would not be there. SF2 would not be there. Okay. SF2 would not be there. That means over here, I'm going to have I'm going to have SV minus SF whole divided by what? SB. This is going to be the relationship in that particular case. This is going to be the relationship. This was the first equation you have. Let us say first equation you have seen is over here. This is the second equation. This over here is the third equation we are having. These equations, if you remember, for apparent weight, it is very, very easy for you to attempt questions in this. Okay. I hope all this thing is clear. I'm going to take one question on apparent weight. Yes. Let me take a question on apparent weight. One moment, please. Okay. This question actually is from your literature itself. This probably in your literature is a question, 1 second. Question number 5 in your literature. How much time do we have? Right. Question number 5 from your literature, probably page number 37 or somewhere around that. Okay, those who don't have books, those who have books can refer to the book. Those who don't have book, let me just mention the question over here. The question says something like this. A body weighs 5 newtons in water and 7 newtons in oil of specific gravity 0.85 or specific gravity 0.85. This much is mentioned. Now the question said in the question asked over there is find the actual weight of the body. I think find the specific gravity of the body is asked. Probably find the specific gravity of the body is asked. I'm changing the question slightly. My question is find the actual weight of the body. Weight of the body. This is the question, let us say. A body weighs 5 newtons in water, 7 newtons in oil of specific gravity 0.85. The question further goes on to say, the question in the book is slightly different. I am asking the question, find the actual weight of the body. This is a good question, easily worth 1 mark in your examination. Find the actual weight of the body. Can also appear for 2 marks, but you'll be very lucky for that. Chaliye. Now ask yourself, a body is weighing 5 newtons in water, 7 newtons in oil. Are these the actual weight of the body? Because actual weight should not change actually, is it not? That means these two are the apparent weights. So apparent weight 1 over here, apparent weight 1 for a body is 5 newtons. It is in water, therefore SF1 is equal to 1.0. Water के लिए SF कितना है? 1. Apparent weight 2 is equal to how much over here? Apparent weight 2 is equal to same body, but placed in a different fluid. It is 7 newtons. 7 newtons. In which fluid? SF2 is 0.85. Okay, this is there. Now what can I do? I can now use this particular equation. Look at this equation over here. This particular equation I can use. This particular equation. I know apparent weight 1, I know apparent weight 2, I know SF1, I know SF2. I can get the value of SB over here. So therefore I can say apparent weight 1 by, see when I write a lot, my handwriting tends to spoil. So please excuse me for that. 1 by 2 has to be equal to SB minus SF1 upon SB minus SF2. Okay. Now, apparent weight 1 by apparent weight 2 is equal to how much? 5 upon 7 is equal to SB minus SF1 is equal to 1 upon SB minus 0.85. From here, get me the value of SB. Please start. Please start. Don't raise hand now, please. Okay. Many of you have given me the answer. The answer is coming out to be, SB is coming out to be 1.375. But in your literature probably only SB is asked, but my question is going further and asking you actual weight of the body is equal to how much? This is the question now. Now what do you do? Now look at the other formula. Let us see the previous slide. You see over here, you are having the value of SB. You are having the value of apparent weight. You want the value of actual weight. You can use this particular equation. So what do you get from here? Let us say I write apparent weight upon actual weight has to be equal to SB minus SF whole divided by SB whole divided by SB. Okay. Please be careful. Please be careful. Whatever apparent weight you take, corresponding SF you should take. ऐसा नहीं होना चाहिए कि you are taking 7 newtons as apparent weight and taking SF is equal to 1. That is wrong. Corresponding SF you have to take. So now I'm writing 5 upon W has to be equal to how much? It has to be equal to SB. SB value is 1.375 minus 1 upon 1.375. From here, you can develop me the value of W. Please start. Okay, very good. The answer over here is 18.33 newtons. 18.33 newtons. This is the answer to the question. Answer to the question asked. I hope this is clear to you, the concept of apparent weight. This is the concept of apparent weight. Yes. Very good. Let us now move further. You can take a snapshot of this particular slide if you want. Moving further. One more category of question that appears in examination is when you're having multiple fluids. When you have multiple fluids which are being displaced by a single body. This is a gate question, previous gate question I'm taking. Every question is either a gate question or a gate level question or IES question or IES level question only. Don't worry. Okay. Gate question I'm taking over here. Probably in mechanical paper this appeared. The question is something like this. Imagine कीजिए. Let us say you're having a particular container. There are two fluids, let us say, in this container. Two fluids are there. One fluid. One second, please. Let me complete the diagram. One fluid over here. Then you have another fluid over here. One second. Another fluid over here. Let us say two fluids you are having. Now what you have done is you have taken over here a wooden block, prismatic wooden block. You have taken a prismatic wooden block. This is a prismatic wooden block, let us say. Fine. Furthermore, you have tied this wooden block to the bottom portion. You have tied this wooden block to the bottom portion using a rope. Okay. Let us say this is water. This is water. This is mercury, let us say, and this over here is wood. Wood. S of wood is equal to, let us say, 0.6. S of mercury, let us say, is equal to 13.6. Suppose this height is equal to 1 meter. This height is equal to 1 meter. This height over here is equal to 0.3 meters. And this height over here is equal to 0.7 meters. This height is 0.7 meters. This is worth 2 mark question. Easy only, like worth 2 mark question. Cross section area, prismatic body है, cross section area is equal to 0.25 meters square. 0.25 meters square. This is a cross section area. The question asked is tension in rope is equal to how much? Tension in rope is equal to how much? This is the question asked. What is the tension in the rope? This is a rope over here. The rope is looking very small. Tension in the rope is equal to how much? See, whenever I give you questions, please participate and first of all straight away draw the diagram. Rough image draw कीजिए आप भी कोशिश कीजिए. You also try. Okay. You might be thinking that you will see all what I'm doing and then you'll get a good practice. नहीं होता वैसा. It does not happen like this. Okay. How much ever you see, you won't get a practice unless you try. I'm creating a duplicate slide. Yes, I hope you have taken all these things. Okay. All these things down. I'm starting the solution now. One second. Let us see. I'm starting the solution now. First of all, I'm going to draw the free body diagram of this entire wooden block. I'm drawing a free body diagram. So let us say the wooden block is something like this. This is the wooden block. First thing that I'm going to show on this wooden block is the weight. First thing is the weight I'm having. Let us say weight of wood. Next, please understand over here, the wooden block is displacing water. It is also displacing mercury. Since it is displacing water, it is going to get some FB upward. Let us say it is getting some FB1. Since it is displacing mercury, it is going to get FB, FB2. FB1 is because it is displacing water. FB2 is because it is displacing mercury over here. Now, at this point, let me tell you, I have seen many people who have doubts regarding this, that why are we having over here FB1 when water is present? Why do we have FB1 over here? Because you see, water is on the side. If you look over here, I accept it, water is on the side. There is no water below so as to create some upward thrust, so as to create some FB on this particular wooden block. But the logic is water is applying. See now how much in detail Pascal's law is. Look over here carefully. Water is applying certain amount of pressure over here on Hg. On Hg. That pressure is acting as if on a constrained, look over here, on a constrained fluid, look at mercury as a constrained fluid over here. On a constrained fluid, there is some pressure developed. That rise in pressure should take place at every point. So this pressure is getting transmitted in this particular direction, and then it is pushing the block upward. I hope you are following this thing. Okay. Because these kind of questions they'll ask in interviews also, that water is not present below, how can you take FV now? They'll ask you like this. Then you have to say it is by which law? Pascal's law. Even though water is not present, in entire statics, presence of fluid is not that much important, but presence of pressure is more important. सब कुछ pressure है, सब कुछ pressure है. If you remember fluid statics के नीचे first thing I wrote was pressure. Everything depends on pressure. Okay. Even though water by itself is not present below over here, but water is creating some pressure which is present below over here, which is creating some FB1 over here. Chaliye, enough discussion on this. There is going to be a certain tension in this particular direction. Tension in this direction. So I can write over here by equilibrium, the value of downward thrusts, that is W plus tension, has to be equal to FB1 plus FB2. I want tension, therefore tension is equal to FB1 plus FB2 minus weight of the wood over here, weight of the wood. Now what is the value of FB1 supposed to be equal to? FB1 is supposed to be equal to gamma of fluid 1 multiplied to volume of fluid 1 displaced. That is equal to how much? What is this value equal to? Gamma of fluid 1 is equal to 9.81. 9.81. Okay, kilonewtons में multiplied to volume is equal to how much? You see now, volume is equal to cross section area multiplied to height. I gave you previously, cross section is 0.25, height is equal to 1 meter. Therefore 0.25 multiplied to 1 meter. Okay, you will get the value of FB1 from here. Next thing, FB2 will be equal to how much? Gamma 2 multiplied to volume 2. Gamma 2 multiplied to volume 2. That is equal to, what is gamma 2 over here? Gamma of mercury. Gamma of mercury कितना रहेगा? 13.6 into 9.81 times volume over here is equal to how much? Again cross section area multiplied to height. अब कितनी height है? अब height 0.3 है. Therefore 0.25 into 0.3. From here you will get the value of FB2. FB2 value you will get. Then weight of wood is equal to how much? Gamma of wood multiplied to volume of wood. Gamma of wood is equal to how much? 0.6 into 9.81. Volume of wood is equal to how much? 0.25 into, how much is this total height? Total height is 0.3 plus 1 plus 0.7. Total height बन गई 2 units. From here you will get this answer. All these things you will get. You will substitute the values in this particular equation. In this particular equation, you'll substitute the values. Then you will give me the value of tension. Please start answering kilonewtons. Start कीजिए please. Why tension is downward? Mechanics बहुत important है. I'll tell you why tension is downward. First of all, finish this off. Many people are giving me answer 9.515. Since that is the most common number I'm getting, I'm taking the answer. I don't have calculator, I'm relying completely on you. Gamma of mercury and gamma of wood is not given, but S of mercury and S of wood is given. That is sufficient. Tension, why it is downward, I'll discuss. First, you finish this off. S of wood is given, S of mercury is given. Therefore, gamma of wood will be equal to how much? 0.6 into gamma of water. Gamma of water is 9.81. Gamma of mercury will be equal to how much? S 13.6 into gamma of water 9.81. Okay. Chaliye. If you have there is no point of BG over here. The reason is you're having multiple B's, right? You're having multiple B's. Chaliye, now regarding tension, how to decide the direction of tension. As a matter of fact, if you would take a wrong direction, for example, many of you seem to have a doubt regarding direction of tension. If you would have taken a wrong direction, for example's sake के लिए, you had taken direction over here, your answer would be negative. If your answer is negative, that basically means आपका direction sense wrong है. Your direction sense is wrong. That means. But still, let us ask ourselves how to take the direction of tension. Tension comes from the word tense. Tense means to tighten something. To tighten something. Okay, let me create a duplicate slide. Please observe. Tension basically means to tighten something. Now, what is getting tightened over here? A rope is getting tightened. Remember, ropes, belts, and all, they can only experience tension. They can't experience compression. They can't experience compression. Imagine that this is a rope you are having. This is a rope you are having. Okay. Straight away, think that this rope should experience tension. Tension जो है हमेशा, it is tightening the rope. It is tightening the rope. Okay. Now this is a wooden block you are having. You see, this T was applied by whom? यहाँ पे Newton's law becomes important. This is on the rope by the wooden block. Wooden block. Suddenly, when you write this thing, what should happen? Newton should come up. Newton should come up. What does Newton say now? Action has been done. इसको action बोल लीजिए आप. If action has been done, there has to be a reaction. What is a reaction? Equal and opposite on the other body. So on the other body is this body, wooden block. तो क्या हो जाएगा? You are going to have on the wooden block by the rope. By the rope. इसको आप reaction बोल लीजिए. Reaction बोल लीजिए. उसी तरह there is a surface below also. There is a surface below. What about the surface below? Where will tension act on surface below? Container का जो नीचे का surface है, even he will experience tension. He will experience tension in the upward direction. Kyun? Because this below surface is pulling the rope down. If he is pulling the rope down, the rope will pull him up. Again, action reaction pair. Action reaction pair. Are you following this thing? Okay. For more details, study mechanics. Okay. Mechanics is the heart of engineering, civil and mechanical both. If you know mechanics, then you know directly the questions nahi aayenge mechanics mein gates. From mechanics you won't get those many direct questions. Can I suggest some book for standard Newton's law and mechanics? See, reading, I can suggest you many books, but how much can you read? That is also a question, no, sir. See, if you want to finish off very, very quickly, you download some PDF of Resnick-Halliday. Resnick-Halliday's PDF you download. Okay, a small within 2-3 pages, you can finish off. If you want to study, this is physics. To study Newton's laws. Okay, within 2-3 pages, you can finish off. If you want to study mechanics in details, I will suggest you Beer and Johnston. Mechanics. But again, you can ask a mechanics faculty for that. I would recommend Beer and Johnston for this thing. Very good book. My notes is enough for GATE. I feel so, sir. My notes are enough for GATE in fluid mechanics. I feel like that. Chali. Let us now move further. Let us take one more question. This question is a difficult question for 2 marks. Today's class, I'm ending at this question. Difficult question, 2 marks. Mechanics again. I will trouble you with mechanics now. Okay. This has not appeared in examination. I'm just saying if it appears, it should appear for 2 marks. Let me first of all draw a good diagram. Imagine you're having some wall. Somewhere over here, you're having a hinge. To this hinge, you're having a wooden rod. You're having some fluid over here. One second. You're having some fluid over here. There is some fluid over here. Let us say this is water. This is water, let us say. This is wood. Okay. Now let me write things down. This is water. This is wooden rod. Wooden rod. S is equal to 0.6. Length of the wooden rod is equal to 5 meters. Length of the wooden rod is equal to 5 meters. One more important thing is this height. This height, let us say, is equal to 1.5 meters is the height over here. 1.5 meters is the height. ठीक है. Let us say this angle theta is equal to how much? I do not know the answers. I am creating the questions over here. I am completely relying on your calculations for answers. Okay, so please be careful. Draw a quick diagram. Jaldi jaldi likho. Diagram draw kar lo. Theta is equal to how much? Prismatic hai, wooden rod, of course. Diagram itself is suggesting it is prismatic. Very good question. Easily worth 2 marks, and it is a difficult question for 2 marks also. Theta is equal to how much? Actually, I suppose you have drawn the diagram. I expect you to be very fast. Okay, I'm leaving this slide. I'm creating a duplicate slide where we are going to solve the question. This is a duplicate slide we are having. Okay. Now, for solving this question, first thing is, it is a question on equilibrium. Whenever you see questions on equilibrium, start with free body diagram. So let us say I'm starting over here with free body diagram. Free body diagram. For free body diagram, let us consider this entire wooden rod. I have seen people who have a habit of changing the orientation of a body while drawing free body diagram. For example, wooden rod slant hai. I have seen people who make it horizontal and then draw the free body diagram. That is a very bad way. It is actually a disrespect towards free body diagram. ऐसे मत कीजिए. जो orientation है उसको maintain कीजिए. Please maintain the orientation while drawing the free body diagram. So this is the orientation we have. Let us say this is the wooden rod I'm having. Okay, assuming that at this particular level, I'm having the fluid. Next thing, what are the forces, various forces acting? Let me take some names now. Naming ceremony over here. This point, let us say some point O. This point, let us say certain point A. We generally have a habit of naming hinges as O. We know at the hinge there are supposed to be two reactions, horizontal and vertical. Again, please don't ask me direction kaise le rahe aap. The logic over here is take any direction. If the answer comes out to be negative for that particular value, it means direction is wrong. Let us say this is horizontal reaction at O. This happens to be vertical reaction at O. ठीक है. Next thing. Exactly at the center, I would assume that there is going to be a certain point G over here. This point G over here is a center. Through this very point, I'm going to have the weight of the rod coming down. Next. Now look, from the interface till this particular end, if you say there is some distance x, मान लीजिए this distance over here is certain distance x. This distance is certain distance x. Exactly at the center of that particular x distance, you're going to have B. Center of buoyancy kahiye isko. Call it a center of buoyancy. From here, you're going to have FB. From here, you're going to have FB. Nothing else is there. Any other force B? Any other force is there? We see no other force over here. Okay. Our aim over here is to identify theta. Our aim is to identify theta. You might ask me, okay, all these things, but where is theta? Logic is simple. To get the value of theta, what I will do is I will first develop the value of x. My first aim is to develop the value of x. Let us say I got the value of x. If I got the value of x, I know that this distance over here is supposed to be equal to how much? The entire length is 5. Matlab ye ho gaya 5 minus x. Okay, let us say I got 5 minus x also. Now look at the triangle over here. Is triangle में hypotenuse is 5 minus x, vertical is equal to 1.5. आप आंसर थीटा निकाल सकते using trigonometry. So first we'll find x, then we'll find 5 minus x by trigonometry. By trigonometry, we can find the value of theta then. We can find the value of theta. I hope you are able to understand the flow of our approach over here. Chaliye. Quickly draw free body diagram. Free body diagram is an art, and you as engineer have to master this art. Shall we start? Free body diagram over here. Now I'm starting the solution. Okay, first free body diagram comes, then solution comes. I see over here that the body is in equilibrium. Rod is in equilibrium. If the rod is in equilibrium, it means that I can apply equations of moment. But there's a problem over here. I see that the forces over here are non-concurrent forces. If non-concurrent forces are there in a 2D system, you have three equations of equilibrium. Sigma fx 0, sigma fy 0, sigma m 0. Always go for, this is my logic, always choose sigma m equal to 0 about a particular point so that maximum number of unknowns are gone. The best point over here is a point O. If I choose sigma m about O equal to 0, HO will not contribute, VO will not contribute, and VO will not contribute. If they don't contribute, only these two are contributing, it will be easier for me to calculate. So now what do I have? I have over here FB creating an anti-clockwise kind of movement. Sorry, FB creating a clockwise kind of movement and W of the rod creating a anti-clockwise movement. Therefore, I can say moment of W about O has to be in magnitude equal to moment of FB about O. I am going slow. Please don't again mention in the question answer that why are you going slow and all those things. See, I'm going slow because everyone has to understand over here. Otherwise, I can solve this question within 2 minutes also. It's not such a big deal. Okay. I want all of you to understand every step over here. So moment of W about O has to be in magnitude, moment of FB about O. Now, what is moment of W about O? Look over here carefully. This is supposed to be the lever arm. With respect to O, this is the lever arm we are having. You know that this distance G to O is equal to how much? G to O distance is equal to 2.5 meters. So I can say that this is equal to, this value is equal to W multiplied to 2.5 into cos theta, because the horizontal component will be equal to how much? If you are having 2.5 and theta over here, it will be 2.5 cos theta. This has to be equal to, now what is this? FB multiplied to, now what is the lever arm over here? The lever arm over here is going to be this distance from here to here. Ask yourself, how much is this distance? For that, you will have to ask yourself, how much is this distance first of all? Ye kitna hai? What is this distance equal to? Now you see, entire length is 5 minus half of x. Therefore, this is 5 minus x by 2. If it is 5 minus x by 2, I can say 5 minus x by 2 whole times cos theta. This is the value.
I can straight away cancel cos theta and cos theta over here. Cos theta and cos theta got cancelled off. Now, what is this W equal to? W is equal to how much? W is equal to gamma of body into volume of body multiplied to 2.5 has to be equal to, what is FB equal to? Gamma of water multiplied to volume of water displaced multiplied to 5 minus x by 2. 5 minus x by 2. Now you see, whenever we see gammas, we can cancel gamma and we can just write S over here. S of water over here. S of water. Now S of body is equal to how much? S of body is equal to 0.6 given in the question. Volume is equal to how much? Volume is equal to cross section area multiplied to complete length. क्या है complete length कितना है? It is equal to 5 multiplied to, चलिए volume is this much multiplied to 2.5. I hope you are following this thing. This will be equal to S of water is 1 multiplied to cross section area. What is the volume of water displaced? Cross section area multiplied to how much length over here? X multiplied to X. Okay, please don't misunderstand. This is cross and this is X multiplied to 5 minus X by 2. Again, I can cancel area and area. Since it is prismatic, area got cancelled off. So what do I have? 0.6 times 5 is 3, 3 times 2.5, 7.5. You are having 7.5 is equal to 5x minus x square by 2, which implies you have a quadratic now, which says x square minus 10x plus 15 has to be equal to 0. From here, get me the value of x. Please start. Please start. This question namesake is fluid mechanics. Otherwise, for me, it is mechanics only. Please be quick, give me the value of x. You should get two values. One will be reasonable, one will make no sense. Okay, I've got the answer from here. One value is 8.16, the other value is 1.83. Two values I've got, 8.16 and 1.83. For sure 8.16 is wrong, because for entire length of 5 meters, how can you have 8.16? Is it not? So it is, answer of course is 1.83 meters. 1.83 meters is the answer. If 1.83 meters is the answer, then what? Then I'm going to the next slide. If 1.83 meters is the answer, this is the rod you are having. This distance x was equal to 1.83 meters. This is 1.83 meters. I'm completing this triangle. We know this is 1.5 meters. This distance over here is 5 minus 1.83 meters, which is equal to 3.17 meters. This is equal to theta. So I can say over here, this is opposite, this is hypotenuse. Therefore, sine theta has to be equal to, opposite is 1.5 meters. Hypotenuse over here is 3.17 meters. So theta is sine inverse of 1.5 divided by 3.17. Chalo, answer bolo. 28.24 degrees, let us say. 28.24 degrees is the answer. 28.24 degrees is the answer for this question. I hope this is understandable to all of you. This is the previous slide we were having, where we got the value of x. Then rest of it is, the second slide has nothing to do with fluid mechanics. It is basic mathematics.
With this, today I'm ending the class. Now you can start putting your hands up. I will allow you to speak. Yes, Shivani Ajiapur. Aljapur. Yes. Hello. Hello.
Hello.
Yes, ma'am. Tell me.
So I have doubt regarding yesterday's question.
Yesterday's question. Which question yesterday's?
Yesterday in one question, so you said that the horizontal force and the net vertical forces are zero.
Okay. That
So how vertical force is zero, sir?
question I took in question answer session, interview question.
Yes, sir. Yes, sir.
Like this was there. In this question.
Yes.
Is it,
Yes, sir.
listen to this. I said that these two are okay. Diagram is not that much neat, but please adjust. These two are parallel curves. Both of them are quarter circles. Let us say AB and CD. AB and CD are parallel quarter circles. Okay. So Fx is fine, man.
Yes, sir.
Fx
Yes,
is
sir.
fine. Fy is a problem. Do you accept Fy over here is down?
Yes, sir.
Do you accept Fy over here is up?
So how Fi is up, sir?
Very good. That is a question. So first question is, how is Fy up? That is the first question you are having.
Yes, sir.
Look at the pressure intensities. They are acting like this. Where will their result in the vertical be?
Okay, up.
Fine. Very good. So do you accept Fy is up now?
Yes, sir.
Okay. All I have to do is, I have to say that Fy's magnitude both cases is same. Question yourself, for this Fy you will take this volume. Correct, na ma'am?
They both get cancelled each other.
Exactly. Good. Have you understood?
Yes, sir. It's
Okay.
clear.
Thank you. Mohammed Jahangir. Mohammed Jahangir Ansari, please speak. Not audible, sir.
Good morning.
Good morning. Good morning.
Good morning, sir.
Good morning, sir. Tell me.
Sir, I have doubt regarding curved surface. Sir, when I was in academics, sir, I have studied. Sir, when I was in academics, I have studied curved surfaces like type 1 surface, type 2 surface. Sir, I am very confused
See, type
about curved surface. Sir, he explained like this flow, water, liquid is below the surface and above the surface.
I'll tell
Sir,
you very
something like that.
okay, I understand. I understand. Even I have heard from some people that they study as case 1, case 2, case 3, and all those things. I first of all don't recommend that kind of studying. Okay, personally, the reason is over there you're killing the logic and you're trying to memorize something. That is not good. Just understand one thing: fluid pushes. Fluid pushes. Imagine you're having fluid up, you're having fluid down. Who cares what is case 1, what is case 2 now? Because, are you able to listen? Hello? 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 Okay, we have lost connection. Pushpendra Dawar, please speak.
Hello.
Hi.
Yes, sir. Am I audible?
Yes, you are audible. Tell me.
Sir, I have a doubt in the weighing machine question.
Weighing machine question. Weighing machine. How will you?
Sir, in this that mass in the middle, it is bound by a string, right?
It is held by a rope. Huh?
Yes, sir. Sir, if the string was not there, then what would happen?
If the string was not there, then the answer on weighing machine would be equal to weight of fluid plus weight of body.
Yes, sir. The body will go down to the surface, right?
Body will, 1 second.
So it will
Body,
touch the bottom.
it might touch, it might not touch. It's none of our concern whether it is touching or not touching. But the answer would be weight of fluid plus weight of body.
No, but sir, if the body is submerged, then it has to go to the bottom. Like,
Why should it go to the bottom? Imagine both their specific gravities are same. It can stay in middle, no? If both the specific gravities are same, it
yes,
can
sir.
stay somewhere in middle. That is also possibility. Okay.
Okay.
But the answer in that case would still be equal to weight of fluid plus weight of body. You can draw a free body diagram for that. It's very simple.
Okay, sir. And I have another question. Another question in that, sir. We had Hg and water in that question. Sir, in this, you said that the water will transfer its force through to the bottom layer. Sir, so it will transfer only the weight it has right now. Like it won't transfer the buoyant force.
Okay, it is transferring the pressure corresponding to this much height. How much is this height? 1 meter height
1 meter.
corresponding pressure it is transferring over here.
Yes, sir.
That is exactly what is FB.
Okay.
No? Okay, no, sir?
Yes, sir. That's it, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Vaishnavi B.
Hello, sir.
Hello.
Sir, could you go to slide number 30? I had a small doubt.
30, huh?
No, previous one. Previous.
Okay, this one.
Yes, sir. So how did we take volume same here, sir?
Tell me, ma'am, is this body completely submerged?
Yes.
If it is completely submerged,
आपने
its volume at one of the...
Sorry, I can't hear you, sir.
Hello, is it fine
Yes,
now?
sir.
Huh.
Yes, sir.
The body is completely submerged. That means whatever is the volume of body and whatever amount of fluid has been displaced, both of them are same.
Yes.
That means for weight of body, you'll have volume of body. For FB, you'll have volume of fluid displaced. Both of them are same.
Okay.
Okay, no?
Okay, sir. Thank you, sir.
Bikash Prasad.
हेलो सर.
Hello, how tell me?
हाँ सर. सर वो कल की क्लास में हमने क्या पढ़ा था सर? वो जब एक सबमर्ज्ड बॉडी होती है अंडर स्टैटिक जो आपने कल पढ़ाया था उसमें एक एच बार और एच स्टार निकाला था.
हाँ.
राइट सर.
जी.
सर तो सर एच स्टार का था कि वो पॉइंट पी के कॉरस्पॉन्डिंग निकल रहा था. तो सर लास्ट वाले क्वेश्चन में जो हम लोगों ने एक बार थोड़ा पार्ट जो सबमर्ज्ड है अंदर पानी के,
मतलब ये क्वेश्चन पूछ रहे हैं आप? ये क्वेश्चन पूछ रहे हैं
जी सर उस पे. हाँ सर. तो इसमें क्या है सर, हम लोगों ने जी
वन सेकंड आई एम सॉरी फॉर इंटरप्टिंग यू. एक बात बोल दूं, ये प्लेट नहीं है, ये एक रॉड है.
सर हाँ जी.
इसमें अब सेंटर ऑफ प्रेशर नहीं आएगा.
हाँ वही
बात समझ रहे हैं? हाँ, इस पे सेंटर ऑफ प्रेशर नहीं आएगा. ये बॉडी है, इस पे बायंसी आएगी. अब आप पूछिए सवाल क्या है.
अच्छा ये बॉडी है तो इस पे बायंसी सर. मतलब क्या है कि इस पे बायंसी आएगी तो एक पॉइंट पे लगेगी ना बायंसी सर की. जैसा एक कोई पॉइंट होगा जिसपे वो पूरा बायंट फोर्स एक फिक्स पॉइंट की तरह वहां पे लगेगा. ठीक है
बिल्कुल
सर. तो वो पॉइंट आपने ऐसे कैसे माना कि सर वो जो सबमर्ज पार्ट है उसके आधे डिस्टेंस पे ही वो पॉइंट लगेगा? उसके लिए हम लोगों ने हाँ सर.
हाँ बोलिए.
हाँ तो इसके लिए हम लोगों ने वो सर एच बार और फिर एच स्टार क्यों नहीं निकाला? मतलब एच स्टार निकाल लेते, उससे कॉरस्पॉन्डिंग थीटा से फिर अपना ये पॉइंट निकाल लेते हॉरिजॉन्टल रोड पे, फिर अपन एफ बी का पता चलता है आपकी पोजीशन क्या है, फिर वहां से थीटा का मतलब फिर वो मूवमेंट बैलेंस कर देते सर.
ठीक है
यही सवाल था.
ठीक है सर. अच्छा, वेरी गुड. नाउ लिसन टू दिस थिंग. आप इमेजिन कीजिए कि लेट मी डुप्लीकेट दिस स्लाइड. आप इमेजिन कीजिए कि ये प्लेट है. अगर ये प्लेट होता तब प्लेट पे प्रेशर इंटेंसिटीज ऐसे होते, तब समझ में आता कि कुछ फोर्स ऐसे काम कर रहा है किसी पॉइंट पी पे. ठीक है सर?
हाँ
हेलो. हाँ.
हाँ
अब ये प्लेट नहीं है, ये कोई वॉल्यूम है. ये कोई वॉल्यूम है और इस वॉल्यूम पे कोई अपवर्ड थ्रस्ट आ रहा है. बेसिकली आप सोचिए, इतना पानी का फोर्स, इतना पानी का वेट है. ये वेट कहाँ पे काम करेगा? पानी का वेट कहाँ पे काम करेगा? उसके सेंटर में ना काम करेगा, है ना सर?
वो अच्छा इसमें क्या था कि सर इसमें भी तो प्रेशर वेरी करेगा ना सर? प्रेशर की इंटेंसिटी नीचे जाते जाएंगे तो बढ़ते.
बिल्कुल वेरी करेगा प्रेशर. लेकिन अब देखिए, यहाँ पे कम था प्रेशर, अब बढ़ते जा रहा प्रेशर. ठीक है, वेरी कर रहा है प्रेशर, बिल्कुल वेरी कर रहा है प्रेशर. लेकिन ये सारे प्रेशर्स एक दूसरे को नलीफाई करते जा रहे हैं, एक दूसरे को नलीफाई करते जा रहे हैं. केवल अब ऊपर की ओर एक प्रेशर आएगा, ऊपर की ओर एक फोर्स आएगा.
हाँ.
You are going to get only a vertically upward force. एक सिर्फ वर्टिकली अपवर्ड फोर्स आ रहा है जो वेट के बराबर है, तो जहां से वेट कॉन्सेंट्रेट होगा वहीं से ना निकलेगा ये।
हाँ मतलब जो सबमर्ज पार्ट है और सबमर्ज पार्ट का वेट जहाँ पे कंसंट्रेटेड है वहां से
हाँ,
वो
वहां से
force
निकलेगा,
ऐसा।
वहां से निकलेगा जी सर।
ओके, और सर पूरे बॉडी का वेट तो मतलब बीच में है, जो कि मतलब इस डायग्राम के हिसाब से वो। हाँ सर, तो एक और क्वेश्चन सर कि ये जो आपने ये बताया कि ये जो मेरा वॉल्यूम है, जो पतली स्ट्रिप आपने बनाई है सर स्क्रीन पे,
ये वाली,
हाँ सर ये वाली,
हाँ हाँ
तो
हाँ।
इसमें और इसमें डिफरेंस क्या बन गया सर? कि इसमें क्या है कि थोड़ा सरफेस एरिया है उसका, उसमें भी तो सर नीचे से प्रेशर आकर के बैलेंस कर देगा और फिर जो अपवर्ड फोर्स बचेगा वो उस पॉइंट से निकाल सकते हैं।
हाँ, लेकिन इसके एप्लीकेशन देखिए, आप मान लीजिए किसी डैम के ऊपर काम कर रहे हैं, आप किसी डैम पे काम कर रहे हैं, पानी एक ही तरफ ना होगा।
हाँ सर।
पानी एक ही तरफ होगा। अगर पानी एक ही तरफ होगा तब ऐसे में क्या बाजू से कोई प्रेशर आके बैलेंस कर पाएगा इसको? नहीं। एप्लीकेशन देखिए इसके, भले मैं माना कि भाई बात सही है आपकी कि यहां से भी प्रेशर आएगा बैलेंस कर देगा, कब बैलेंस करेगा? पानी दोनों तरफ होगा। लेकिन हमारे जितने एप्लीकेशन है वहां पानी सिर्फ एक ही तरफ रहता।
अगर कल वाले एग्जांपल में सर दोनों तरफ पानी था, वो वाला क्वेश्चन में बैलेंस हो सकता है? कल वाला सर जब आपने एस स्टार और एच बार का वो फिगर बनाया सर उसमें,
हाँ, उसमें इसीलिए तो उसमें मैंने अज्यूम किया था कि भाई उसमें तो इसीलिए मैं अज्यूम किया था कि ऑन वन साइड ऑफ द प्लेट बोल के अज्यूम किया था ना भाई। आप ये स्लाइड देख सकते हैं, कल का स्लाइड है ये, इसीलिए वहां पे मेंशन किया गया था ऑन वन साइड ऑफ द प्लेट, क्योंकि समझने के लिए पहले ये लिया गया, उसके बाद एप्लीकेशंस वैसे निकले उसके। ठीक है
सर, मेरा बहुत बड़ा डाउट क्लियर हो गया। वन साइड ऑफ द प्लेट शायद मैं सर छोटा सा मिस कर गया था, इसलिए मेरे को ये अभी ऐसा डाउट आया। अभी समझ गया सर मेरे को।
थैंक यू सर,
थैंक यू सो मच।
I am speaking to Harish now. Mr. Harish, please unmute yourself. Good morning, sir.
Good morning, sir.
Yes, good morning.
I have a doubt in 23rd page. Could you please go back? 23rd page.
Yes, sir.
So in second line of first point, FB equal to weight of fluid displaced will be also equal to weight of body, na sir. Volume is equal to same, na sir. Then how weight equal to same? Both are having different gamma values, na sir.
FB is equal to weight of fluid displaced. Okay, you're saying this black part over here.
Yes, sir.
FB, which is actually equal to weight of fluid displaced, will also be equal to weight of the body. Yes, what is wrong in this? See, imagine this particular body over here. You're looking at this body over here.
Yes.
On this particular body, how many forces are there, sir?
2, sir.
Only 2. Is this body accelerating anywhere?
No, sir.
No. That means the body should be in equilibrium.
Yes.
Okay. If the body is in equilibrium, that means whatever is the value of FB should be equal to weight of body also. That is what I have written.
Okay,
now,
sir.
your doubt over here is their volumes are different. Is this the doubt? Is this the doubt, sir?
Volumes are same. How weights are?
No. Volumes are different. Volumes are different. The volume of fluid displaced. You see how much is the volume of fluid displaced over
partially
here?
submerged, no?
It is this much only. It is this much only. Volume of fluid displaced is the shaded portion. Volume of body is bigger portion.
Yes, sir.
Is it fine now?
Oh, okay, sir.
No.
I got it.
Anything else, sir?
And no else.
Fine then. Mohammad Jahangir Ansari. I'm not able to.
Sir, I have lost connection. That's why.
Okay, no problem, sir. देखिए, आपके पीछे से बहुत डिस्टर्बेंस आ रहा है. If anyone is speaking, ask them to keep quiet for some time. Okay.
जी सर बताइए.
देखिए सर, आप बोल रहे थे कि कई केसेस से मतलब केस 1 केस 2 ऐसे याद किया था आपने किसी मतलब शायद अपने कॉलेज में एंड ऑल, तो वहां से जो आप पढ़े थे और यहाँ पे पढ़ रहे हैं उसमें कंफ्यूजन लग रहा है आपको. ठीक है, ये था आपका?
जी सर.
हाँ, देखिए सर, मैं जो है
सर तब भी नहीं समझ पाए थे और अब भी नहीं समझ पाए सर, इसी बीच आप तो कंफ्यूजन में हो गए.
बहुत अच्छे, वेरी गुड. देखिए, वो छोड़ दो, आप वो भूल जाओ. वो इसलिए भूल जाओ क्योंकि मैं वो नहीं पढ़ा रहा हूँ.
नहीं सर, इसीलिए आप जब पढ़े ना तो वो चीज माइंड में आ रही तो आप कंफ्यूज हो गए.
ठीक है, वो भूल जाइए इसीलिए. ठीक है, क्योंकि हम तो वो नहीं पढ़ाएंगे, इसीलिए आप वो भूल जाइए. हम क्या पढ़ाएंगे, बहुत ही लॉजिकली पढ़ाएंगे आपको कि भाई फ्लूइड हमेशा पुश करेगा. अच्छा, फ्लूइड मान लीजिए पुश कर रहा है, तो बताइए, इतना लॉजिक लगाइए, आपके पानी यहाँ पे है, इस MN प्लेट पे कहाँ पे पुश करेगा फ्लूइड? x में कहाँ पे पुश करेगा, राइट में पुश करेगा कि लेफ्ट में पुश करेगा?
सर
राइट में
तरफ, mn की तरफ, mn की तरफ,
mn की तरफ। उसी तरह यहाँ पे अगर mn है तो राइट में पुश करेगा, लेफ्ट में पुश करेगा?
फिर mn की तरफ करेगा, मींस लेफ्ट की तरफ।
वेरी गुड। अच्छा बताइएगा कि fy कहाँ पे होगा, नीचे की तरफ या ऊपर की तरफ?
fy नीचे की तरफ।
नीचे की तरफ। फ्लूइड पुश करेगा, याद रखिए, इतने इतने स्टेटमेंट को याद रख लीजिए आप, ये तो आसान है। अब बताइए fy कहाँ पे होगा, नीचे की तरफ के ऊपर की तरफ?
ऊपर की तरफ।
परफेक्ट सर, यहाँ तक सही है आपका। अब आपको केवल जो है fy के लिए, fx तो मेरा ख्याल है कोई दिक्कत नहीं है आपको?
नहीं, fx समझ में आता है।
ठीक है, fy जो है केवल गामा टाइम्स वॉल्यूम लेना है। अब आपके दिमाग में आना है कि वॉल्यूम कितना लिया जाए, बस इतना याद रखो, वॉल्यूम ऑलवेज फ्रॉम इंटरफेस, ऑलवेज फ्रॉम इंटरफेस टू कर्व्ड सरफेस। कुछ भी हो जाए, आधी रात में उठा के पूछूं मैं आपको, तब भी आप यही बोलेंगे, बिना सोचे बोलेंगे कि वॉल्यूम ऑलवेज फ्रॉम इंटरफेस टू कर्व्ड सरफेस। यहां भी इतना ही वॉल्यूम लीजिएगा, यहां भी इतना ही वॉल्यूम लीजिएगा, भले पानी ना भी हो तब भी इतना वॉल्यूम लीजिएगा। हो गया आंसर?
जी
ठीक है,
यही चीज सर कंफ्यूजन कर रहा था कि इधर तो वाटर नहीं है, इधर वाटर है, तो फिर हम कैसे
अगर आपको उसका कॉन्सेप्ट समझना है तो इतना समझिए कि यहाँ पे जो ऊपर में प्रेशर लग रहा है, ध्यान से सुनिएगा, यहाँ पे जो ऊपर में फोर्स लग रहा है वो प्रेशर से लग रहा है, सही है? सही है सर
जी।
फोर्स इज ड्यू टू प्रेशर, ड्यू टू प्रेशर। अब प्रेशर इज ड्यू टू विच हाइट? इज इट द हाइट फ्रॉम इंटरफेस और हाइट फ्रॉम बॉटम? बोलिए बोलिए सर। प्रेशर जो है कितनी हाइट के हिसाब से लेंगे आप? हाइट फ्रॉम इंटरफेस से लेंगे ना सर? आई एम नॉट एबल टू लिसन टू यू। हाँ, तो प्रेशर इज ड्यू टू हाइट फ्रॉम इंटरफेस, हाइट फ्रॉम इंटरफेस। अब मान लीजिए छोटे से पोर्शन के लिए आप हाइट फ्रॉम इंटरफेस लेते जा रहे हैं, अगले पोर्शन के लिए हाइट फ्रॉम इंटरफेस, अगले पोर्शन की हाइट फ्रॉम इंटरफेस लेते जाए, कौन सा वॉल्यूम कवर हो जाएगा सर, ऊपर वाला कि नीचे वाला? ऊपर वाला ना होगा?
ऊपर वाला।
अब क्लियर है बात?
हाँ सर क्लियर।
अब बस इतना याद रखिए, आप पुश करेगा।
जी
आवाज बहुत ब्रेक हो रही है
सर। क्वेश्चन सॉल्व करेंगे फिर जी सर, क्वेश्चन सॉल्व करेंगे फिर चेक करेंगे सर, क्योंकि सर दोनों कॉन्सेप्ट दोनों कॉन्सेप्ट जो है वो एकदम मिल गए थे, तो समझ नहीं आ रहा था क्या करें। हम कहा था कि स्टैटिक्स, फ्लूइड स्टैटिक्स जो है बहुत ब्लंडर कर दिया है।
नहीं कोई बात नहीं सर, आप एक काम कीजिए, सवालात कीजिए, फिर अगर दिक्कत है तो फिर से वी कैन डिस्कस। ओके ना सर?
ओके सर, थैंक यू।
थैंक यू सर।
थैंक यू
सर। हरीश्री अरुण, please unmute yourself.
Good morning, sir.
Morning, ma'am. Tell me.
Sir, I have a doubt in the slide number 31F.
31F, okay.
So in that, so we took apparent weight is equal to 5 by W. Why we took 5, sir?
One second. This one?
Yes, sir.
Oh, this is not compulsory. You could have taken 7 also. Okay, you could have taken 7 by W, but you would have written over here. Tell me, how much would you write over here?
It's 0.85.
Perfect. 0.85 divided by 1.375. You would still get the answer. Same thing only. Only thing is, whatever apparent weight you take, corresponding value of SF is supposed to be taken. Why have I chosen 5 personally is because it is easy to subtract 1.37 minus 1, right? That's the only reason I have taken. Okay, no other reason as such.
Okay. So one more doubt was this. I have sent one question, sir, in WhatsApp, sir.
Okay. Actually, I am getting lots of questions, so I'm not able to answer them on time.
That sent it in morning now also, so I sent it.
Morning only. Fine, I'll look into it. I'll try and look into it. But please don't mind if I'm not able to reply on WhatsApp because I get many messages, so it's not possible every time. Fine.
It's a doubt on manometer, sir.
Okay, fine. I'll try to look into it.
Okay, sir. Thank you, sir. Thank
you. Hello.
Hello, sir. Good morning.
Good morning, sir. Tell me.
Sir, in yesterday's question, homework problems.
Homework problem is sir. I tried to write everything down so that you could understand properly. Tell me 1 second.
Yes, sir.
1 second. This problem, huh? This problem, sir.
Yes sir. Yes sir.
Tell
Yes
me,
sir.
what is the difficulty?
Sir, why did we take like E greater than or equal to GH in the next
Okay,
slide?
sir. Just
Sir, because
imagine.
I have thought like the force will be acting at the point P, and it
At
will
the
act
point of
at the point P.
P, yeah, perfect, huh?
So the moment which will be created by F with the lever arm HP. So that should be the thing, no sir, which will oppose the gate and it will remain closed.
Okay, let me answer you in a different way. Please respond to me.
Yes sir. Yes sir.
Look over here. Imagine I'm drawing the free body diagram of the gate. Imagine I'm drawing the free body diagram of the gate. This is the gate, let us say.
Yes sir.
Let me make a bigger one otherwise. This is a gate, let us say.
Okay sir.
This is a point A. This is certain point B. This is a let us say exactly center O. This is H. I believe there is no problem with this. The distance between OH is equal to 0.1 meter. Till here, everything is fine, sir?
Yeah. Till here I got.
Okay. Now you see, this gate can rotate about which point? Hinge.
About the hinge.
About hinge, it can rotate. So let us say hinge is something like this. It can rotate about hinge.
Okay, sir.
Now, do you want it to rotate or not rotate?
It should not rotate.
It should not. Perfect. The aim is the gate should remain closed. That is why it is called a gate.
Yes, sir. Yes.
Acha, tell me, there is going to be for sure there is going to be a horizontal force coming.
Yes, sir.
In the rightward direction on this side of the plate.
Yes, sir.
Where would you want to keep it? Above H or below H?
Below H only. Below H only.
Because you see, you're having a support over here. You're having a certain support over here. You would want to keep it above H or below H?
Below the H.
Below H. So you would want to keep it below H. Okay, fine. This force is F, and this point it is going to act at is going to be the point P.
Center
of pressure.
Yes,
and the distance over here is going to
be eccentricity.
Eccentricity. Perfect.
Yes.
You have only mentioned that it should be below H.
Yes,
that
sir.
means it should be, the value of E should be at least 0.1 meter, ideally more than 0.1 meter. Correct, sir?
Acha. Sir, once more, sir.
Again, no problem. If you're not following, feel free to say you're not following.
Sure, sir. Sure. I'm not convinced, sir.
Perfect. I don't want you to get convinced also. I want you to understand and rather.
Yeah, that's what. Okay.
देखिए, you are fine with the force should be below H. यहाँ तक ठीक है? We are together?
Yeah, यहाँ तक ठीक है, sir.
ठीक है यार, और E जो है ये डिस्टेंस है.
Yes, sir.
अगर आप हिंदी बात करते हैं?
Yes, sir. हिंदी में बात कर सकते हैं.
अगर आप चाहते हैं कि फोर्स जो है H के नीचे हो,
okay.
फोर्स जितनी दूरी पे होगा O से, उसी को ना E कहेंगे.
अच्छा सर, मैं जो सोच रहा था ये F जो है,
हाँ जी,
E माइनस 0.1 के थ्रू जो करेगा, मतलब उस टाइम गेट ओपन नहीं होगा. E माइनस 0.1, तो ये वाला जो HP पार्ट है,
E माइनस 0.1,
या तो HP जो आ जाएगा ना सर, HP का डिस्टेंस.
हाँ.
तो वैसा मैं सोच रहा था सर.
नहीं देखिए सर, आप देखिए
इस कॉन्सेप्ट में भी गेट क्लोज्ड ही रहेगा ना सर.
अच्छा, E माइनस 0.1 वाली कितनी होनी चाहिए आप बोल रहे हैं
सर? एक्चुअली उसमें भी तो y का टर्म आ रहा है, तो वही मेरे को मतलब ये एनालिसिस करने में प्रॉब्लम हो रहा.
देखिए इस बात इतनी से E माइनस 0.1 तक जाने की जरूरत नहीं है. बात ये है कि हम चाहते ही नहीं कि गेट ओपन हो ना.
यस सर.
गेट ओपन नहीं होने के लिए F H से नीचे होना चाहिए.
यस सर.
है ना? F should be below H. अच्छा, ये जो डिस्टेंस है O का, O को आप क्रिएट कर दीजिए, क्योंकि O इंपॉर्टेंट है, उसी के हिसाब से E डिफाइन किया गया है. O से जो डिस्टेंस है उसी को हम E कहेंगे.
ओके, यस सर.
हाँ, अब मैं देखिए मिसाल के तौर पे, फॉर एग्जांपल लेट अस से मैं F को यहाँ प्लेस कर रहा हूँ, H के ऊपर प्लेस कर रहा हूँ. फेवरेबल है या अनफेवरेबल है?
नॉट फेवरेबल.
नॉट फेवरेबल. अब यहाँ पे क्या है, E जो है 0.1 से कम है.
या ओके.
अब यहाँ पे प्लेस कर रहा हूँ, H पे प्लेस कर रहा हूँ. ये फेवरेबल ठीक है, मतलब एक क्रिटिकल कंडीशन है, यहाँ पे गेट खुलेगा नहीं, बस खुलने पे है.
ओके
अब ये कंडीशन है E इक्वल टू 0.1 है,
यस सर
अब नीचे रख रहा हूँ फेवरेबल है,
ओके ग्रेटर देन
ग्रेटर देन, इसीलिए हम लिखे यहाँ पे E ग्रेटर देन और इक्वल टू बेसिकली
अच्छा
0.1।
सर
ठीक है ना?
मैं जो
हाँ,
एनालिसिस बोला था उसमें एफ इंटू एच पी अगर करेंगे तो
करेंगे
अबाउट द
ओके,
पॉइंट
F इंटू एच पी करेंगे, आपको कुछ मूवमेंट आ जाएगा। ओके मूवमेंट आ गया, इससे क्या करेंगे?
वो सर वो मूवमेंट जीरो होना चाहिए ना, मतलब
नहीं, मूवमेंट क्यों जीरो होना चाहिए?
सर
अब यहाँ पे आप एक बड़ा ब्लंडर कर रहे हैं, आप नहीं देख रहे कि यहाँ से एक रिएक्शन आने वाला है,
ओ ओके 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 ओके
यहाँ से एक रिएक्शन आने वाला है,
अच्छा अच्छा
और ये रिएक्शन वेरिएबल रिएक्शन है।
यस सर
आप F को कहीं भी रखिए, उसका वेरी करते जाएगा, वो हिसाब से वेरी करता, सेल्फ एडजस्टिंग रिएक्शन है ये। ठीक है ना सर?
अच्छा
अब एनालाइज कीजिए, ठीक है ना सर?
या सर अभी समझ में आया सर,
थैंक यू सर,
थैंक यू सो मच सर,
थैंक यू सर, थैंक यू। कल्पेश राजपूत।
हाँ सर, जो पार्शियली सबमर्ज का केस आपने अभी लिया है,
पार्शियली सबमर्ज्ड, एक सेकंड, आज की क्लास में पार्शियली सबमर्ज्ड मतलब कौन सा क्वेश्चन बोल रहे हैं आप?
अभी हरीश ने पूछा था वेट ऑफ फ्लूइड इज इक्वल टू वेट ऑफ बॉडी।
अच्छा, वन सेकंड, स्लाइड नंबर याद रख लो यार आप लोग, डाउट्स है तो। एक सेकंड, हाँ ये वाला,
हाँ सर, इसमें बायंसी फोर्स is equal to weight of fluid displayed and it is equal to weight of body।
जी
हाँ, तो सर वेट ऑफ फ्लूइड का फॉर्मूला लिखा तो वॉल्यूम ऑफ फ्लूइड इनटू
गामा ऑफ फ्लूइड,
गामा डब्ल्यू,
गामा ऑफ
और
फ्लूइड,
वेट ऑफ बॉडी इक्वल टू वॉल्यूम ऑफ बॉडी गामा ऑफ बॉडी।
यस सर।
सो तो सर वेट ऑफ फ्लूइड इक्वल टू वेट ऑफ बॉडी कैसे हुआ?
कोई बात नहीं, अच्छा वेट ऑफ फ्लूइड
क्योंकि ये केस में वॉल्यूम ऑफ फ्लूइड तो पार्शियली इतना ही लेवल तक ही फ्लूइड है, और वॉल्यूम ऑफ बॉडी तो पूरा पोर्शन का आएगा।
ठीक है सर, कोई बात नहीं। अब देखिए, वेट ऑफ फ्लूइड इज इक्वल टू गामा ऑफ फ्लूइड इनटू वॉल्यूम ऑफ फ्लूइड, सही है सर?
हाँ सर।
अच्छा, वेट ऑफ बॉडी इज इक्वल टू गामा ऑफ बॉडी इनटू वॉल्यूम ऑफ बॉडी, सही है? सही है ना यहाँ तक?
हाँ सर।
अच्छा, आप बोल रहे हैं कि यहाँ पे वेट ऑफ फ्लूइड कम है, वेट ऑफ फ्लूइड कम है, हालांकि वेट ऑफ बॉडी ज्यादा है, ये बोल रहे हैं ना आप?
हाँ, वो वॉल्यूम, हाँ
कोई दिक्कत नहीं है, गामा ऑफ फ्लूइड ज्यादा है, गामा ऑफ बॉडी कम है। अगर ये कम है तो ये तो ज्यादा है ना।
हाँ,
जब फ्लोट करेगा बॉडी, जब गामा ऑफ फ्लूइड ज्यादा होगा गामा ऑफ बॉडी, तभी ना फ्लोट करेगा। हेलो सर, आर यू फॉलोइंग?
बैलेंस करेंगे दोनों।
एग्जैक्टली, जितना भी वॉल्यूम कम है उतना ज्यादा गामा होगा, ताकि बैलेंस कर जाए। ठीक है ना सर?
ओके, मतलब मैग्नीट्यूड वाइज तो डिफरेंट रहेंगे, सिर्फ बैलेंस करेंगे।
हाँ, मतलब ये प्रोडक्ट जो है, गामा एफ इंटू वॉल्यूम वाला प्रोडक्ट जो है, और गामा बी इंटू वॉल्यूम बी वाला प्रोडक्ट जो है, वो दोनों एक दूसरे के बराबर हो जाएंगे।
ओके सर,
ओके फाइन,
गॉट इट सर,
थैंक यू सर,
थैंक यू सो मच,
नो प्रॉब्लम सर। श्री रानी, hello
sir.
Hello, tell me.
Actually, I have a doubt in today's last question, sir.
Today's last question, this question.
Yes, sir.
One second. Tell me.
Sir, in this case also same like hydrostatic force on plane bodies, sir.
Plates. No, this is not at all flat plate. This is a rod. It is a complete body. This is a rod, not a flat plate. Don't apply the concept of flat plates.
But you said the force of buoyancy is the body force by the fluid.
Yes, ma'am.
In this case, the force of buoyancy top of the fluid also acts on the plate, na?
Plate is not there, madam. Body is there. You are saying that this particular part, the top more, the upper part is also going to act, and the lower part is also going to act. You are saying, is it this thing? Hello.
Yes, sir.
No,
yes, sir.
It is not like, there is no upper lower part over here. Imagine this marker, this pen you can see over here in my hand.
Yes.
This is not a plate. It is a rod. Let us say this is a rod. Let us say Fluid is completely enveloping over here, completely enveloping throughout 360 degrees throughout. Okay. There is no upper portion, lower portion. I said there is no portion like this. There is only one force which is coming, that is FB force, which is vertically upward forces coming over here. Then upper lower will come when you are having a plate, a sheet with zero thickness, when you are having a fluid like this, then upper and lower will come into picture. This is not a plate case. No?
Okay, thank you.
Thank you, ma'am. Shibin Shahid.
Sir, buoyancy is caused due to the fluid, right?
Buoyancy is caused due to the hydrostatic pressures.
So, if the body is in the bottom of the surface, will there be buoyant force?
1 second. This is actually an interview question which was asked in BARC examination. I think you are indicating towards this question, thinking that there's a container. You are having a body which is placed over here, and then you are having some fluid over here. Is this the question you're asking?
Yes, sir.
Okay, very good. This was actually a BARC question. BARC interview question. In this particular case, there is no buoyancy. There is only going to be a pressure force over here, which is equal to, imagine this height is h. The pressure force will be equal to gamma into h multiplied to whatever is the area. There is no buoyancy over here because technically this body is not displacing any fluid. Is it not? This body is a part of a container now. It has not allowed any fluid to go below. Imagine if the fluid is able to go below and the fluid is in continuous contact. Imagine, let us call this as parent fluid. Some portion is able to go below and is in continuous contact with the parent. Then what will happen? This body has technically displaced the fluid. But right now, tell me, is it displacing the fluid technically?
No.
No, that is why there is no buoyancy over here. It is just gamma into h multiplied to area. This is just hydrostatic force on the bottom plate. Is it fine?
If the bottom material was a rectangular block, will there be?
Okay, you are saying that if it is a rectangular block like this.
Yes.
Again, the question arises over here. What can you say regarding the fluid over here? Is there any chance of fluid in contact over here? If this is perfectly in, that means if the block and the surface below, they are in so much contact that there is no chance of even a single molecule of fluid below, it is as if it is welded now.
Yes, sir.
In that case, there is again no buoyancy.
Oh.
Please understand, for buoyancy to occur, there should be some chance of pressure force to go below. I'll give you an example, sir. I'll give you an example. I said over here that water is above. But how did the water's force of buoyancy come up over here? The reason is water's pressure force could get transmitted over here. Correct, sir?
Yes, sir.
Is that a possibility over here?
No.
That's why there is no buoyancy over here. This is actually a very standard interview question. Is it clear, sir?
Yes, sir.
Okay. Anything else? Hello? Fine. Anyone wants to raise hand? I'm waiting. One second.
Hello.
Hello. Hello.
Good morning, sir.
Morning,
Hello,
sir.
Sir, can you go to the slide number 21F?
21F. 1 second. 21F. Tell me.
Sir, can you make me understand the second point, the net vertical thrust on the body?
Okay, due to the hydrostatic, at this point where my cursor
Yeah,
is.
I didn't understand the logic behind it.
Okay, sir. Imagine this is the body you are having. Pressure intensities are like this. Pressure intensities are like this. Fine.
Yes, sir.
Now tell me, if I look from here, let us say you are looking from here, I am looking from here. Okay. You are saying some area projected. I am saying some area projected. Are both area projected be same?
Yes, sir.
They will be same. You are looking at some h bar. I am looking at some h bar. Will they be same?
H bar.
They will be same.
Yes, sir.
Areas are exactly same. Location of areas are exactly same. H bar will be same. That means fx got cancelled off. Net fx is equal to how much? 0. Correct? Okay. The problem with Fy is this pressure intensity is smaller. This pressure intensity is bigger.
correct?
Yes, sir. Due to depth of water na.
Exactly. Depth यहाँ पे ज़्यादा है. Depth is more over here. इसीलिए pressure ज़्यादा है.
Yes.
That means if this pressure is less, what is happening? He is able to exert lesser downward force. He is able to exert more upward force.
Okay.
हाँ, तो मतलब क्या हो गया? Upward force, downward forces ज़्यादा है. So net force should be in which direction?
Upward.
That is what the statement is saying over here. That is exactly what the statement is saying.
Yes, sir. Got it.
ठीक है sir. Thank you.
Thank you, sir.
Anyone else? Anyone else who wants to speak?
Hello, sir.
Hello, Sai Mahesh, tell me.
Yes, sir. In the same bar question.
Okay, that question. Oh, one second.
If there is a sphere, also there will be no buoyancy, no, sir.
If there is a sphere, then there will be a chance of buoyancy coming up. The reason is, if there is a sphere, imagine there is a sphere. At least one portion of upward thrust has come in, na, sir. Some portion of upward thrust has come in.
Yes, sir.
Then buoyancy is coming in over here. In the case of rectangle, there is no chance. Sphere, which chance is there? Okay.
Okay, sir.
Thank you, sir. Anyone else? Anyone else? Srikanth. Miryal Srikanth.
Can you hear me, sir?
Yes, sir. Hello.
Can you hear me, sir?
Yes, I can. Tell me, sir. Tell me.
Sir, I asked silly, don't mind.
No problem. I won't mind, sir. I won't mind. Tell me.
We can swim in water. How can we swim in water?
How can we swim in water? Means, tell me, why do you swim in water? Huh? Again? Hello?
We float in the water. How can you say that?
How can we float in water?
Float in water. We are swim now.
Yes.
How we can say that?
When you apply some kind of
the
thrust,
forces acting on the body.
see, when you are applying some kind of thrust, you are no more in a static condition. You are in a dynamic condition. In that case, you can float. If you are, for example, you can swim because you are applying some kind of thrust. Is it not? You are not just keeping quiet.
Yes,
If you just keep quiet, you will drown.
Yes, sir. Yes.
Fine. Thank you.
Okay.
Thank you, sir.
Hello, sir. One more thing, one more statement which you have told regarding this, the weighing machine concept, sir.
Tell me.
Sir, the weighing machine will read the normal reaction.
Yes, sir.
Because you told one statement. Can you repeat that one, sir? Because the weight
does not act on the weighing machine. Weight acts on the body. Weight is actually a force exerted by earth on body.
Acha, by earth on the body.
You go through, if you have time, you go through.
Okay.
Westlake Halliday or Paul Tipler, one more book is there. Paul Tipler, Physics, very good book. Any other books? You download PDF. Don't buy these books, okay?
Okay.
You won't find that much time to read.
Yeah.
Easily you'll get.
Okay.
Just go to the concepts once. It is very simple. Right?
Okay, sir. Okay, sir. Thank you.
Thank you. I'm closing the session for today. Thank you.